Welcome to the Whispering Scientist, where the vast cosmos reveals its most intimate secrets through gentle exploration and wonder-filled discovery. I'm here to guide you on journeys that span billions of light-years while bringing you closer to the profound truth that you are not separate from the universe, but rather its most precious expression. Matter that has learned to contemplate itself. Perhaps you're settling into the quiet embrace of evening, your room softened by dim light, the day's urgencies finally releasing their hold on your thoughts. Maybe you're lying beneath a canopy of stars, or simply closing your eyes and allowing your mind to drift toward the infinite mystery that surrounds us all. Wherever this moment finds you, know that you're about to discover something extraordinary. The Milky Way galaxy is not just your cosmic address, but your extended body, the vast living system that has spent over 13 billion years preparing the conditions necessary for your existence. Tonight, we're going to explore how our home galaxy is far more magnificent, far more alive, and far more intimately connected to your very being than you've ever imagined. That faint ribbon of light you've glimpsed arching across dark skies isn't merely a distant collection of stars. It's a breathing, evolving cosmic organism that has nurtured every atom in your body, guided every breath you've ever taken, and continues to embrace you with forces so gentle yet profound that they shape the very fabric of space and time around you. When you gaze upward at that ethereal band we call the Milky Way, you're witnessing your cosmic home from the inside, like standing within a vast cathedral of light and trying to comprehend its true architecture. The galaxy appears as a thin, luminous river because you exist within its disk, seeing it edge on through countless layers of starlight, interstellar gas, and cosmic dust that have been dancing together for aeons. Each glimmer you can distinguish represents not just a single star, but often entire stellar neighborhoods, communities of suns that have been waltzing through space together since before Earth formed its first oceans. Our galaxy stretches approximately 100,000 light-years from edge to edge, a distance so vast that light itself, traveling at the universe's absolute speed limit, requires 100 millennia to cross from one spiral arm to another. This span exceeds the entire duration of human civilization, surpasses the age of our species, and dwarfs every historical timeline we use to measure earthly events. Yet this immense structure rotates as a single, unified system, completing one graceful revolution every 230 million years. Since complex life first emerged on Earth, our solar system has completed fewer than 3 full orbits around the galactic center, making each galactic year longer than the entire evolutionary journey from simple cells to human consciousness. Within this cosmic spiral dance live between 200 and 400 billion stars, each one a nuclear furnace converting hydrogen into heavier elements, forging the building blocks of planets, atmospheres, and life itself. Among these stellar multitudes, our Sun occupies no privileged position. It's neither the largest nor the brightest, neither the youngest nor the most ancient. It's simply one voice in an incomprehensible cosmic choir, singing the same fundamental song of nuclear fusion that has illuminated the galaxy since shortly after the universe began cooling enough for the first stars to ignite. Yet within this apparent ordinariness lies profound beauty and meaning. Our solar system resides in the Orion Arm, a minor spiral branch located roughly 26,000 light-years from the galactic center. This position places us in what astronomers call the galactic habitable zone, neither too close to the violent, radiation-soaked core, nor too far out in the sparse, metal-poor outer regions where heavy elements necessary for rocky planets remain scarce. We exist in a cosmic sweet spot where stellar encounters are rare enough to allow stable planetary orbits across billions of years, yet where supernovae occur frequently enough to enrich our local environment with the carbon, oxygen, nitrogen, and iron essential for complex chemistry and life. The heart of our galaxy harbors one of the universe's most mysterious and powerful objects, Sagittarius A, a supermassive black hole containing over 4 million times the mass of our Sun, compressed into a region smaller than our solar system. This gravitational anchor doesn't destroy the galaxy, it organizes it, providing the central mass around which hundreds of billions of stars maintain their ancient orbital dance. Recent observations have even captured direct images of this black hole's shadow, revealing the glowing accretion disk of superheated matter spiraling into its inescapable embrace, transforming gravitational energy into brilliant radiation that illuminates the galactic core. Between the stars lies not emptiness, but a rich, dynamic medium of gas and dust, the raw material from which new stars continuously form, and the repository where dying stars deposit their nuclear ashes. These stellar nurseries, often visible as colorful nebulae, represent the galaxy's ongoing process of renewal and transformation. When massive stars exhaust their nuclear fuel and explode as supernovae, they scatter heavy elements throughout space, enriching the interstellar medium with the carbon, oxygen, silicon, and iron that will eventually become incorporated into new planetary systems and potentially new forms of life. Every element in your body, except hydrogen, was forged in the nuclear furnaces of stars that lived and died before our Sun ignited. The calcium strengthening your bones, the iron carrying oxygen through your bloodstream, the carbon forming the backbone of your DNA, all were created in stellar cores and distributed through space by stellar winds and supernova explosions. You are not merely living within the Milky Way, you are literally made from it, a temporary arrangement of galactic matter that has achieved the remarkable ability to contemplate its own cosmic origins. As you rest tonight, remember that you're not separate from this magnificent cosmic story. You're its most precious chapter, the universe's way of experiencing wonder about itself through conscious eyes. This profound connection between your physical being and the cosmic architecture surrounding you becomes even more remarkable when you begin to perceive the Milky Way's true hidden structure. What appears from your earthbound perspective as a simple, ethereal band of light stretching across the night sky conceals one of the universe's most elegant and sophisticated designs. You are witnessing our galaxy from within, like standing inside a vast cathedral of stars and trying to comprehend its full architectural majesty while surrounded by its luminous pillars and soaring arches. The reason the Milky Way appears as that familiar, hazy river of light is beautifully simple. You exist within its disk, seeing it edge on through countless layers of starlight, interstellar gas, and cosmic dust. Imagine standing within a dense fog where distant city lights blur into an indistinct, uniform glow. The thicker the mist becomes, the more diffused and continuous the illumination appears. Similarly, when you gaze upward at that celestial band, you're looking through the galaxy's own fog, vast clouds of interstellar material that scatter and absorb starlight, creating those mysterious dark patches that seem to divide the Milky Way into segments. These aren't empty voids, but immense curtains of cosmic dust, each grain smaller than a particle of smoke, yet collectively capable of obscuring entire stellar neighborhoods and sculpting the sky into the textured, varied landscape of light and shadow you observe. If you could somehow step outside our galaxy and view it from the cosmic void beyond, the transformation would be breathtaking. The Milky Way would reveal itself not as a thin ribbon, but as a magnificent spiral galaxy, its luminous arms unfurling in graceful, logarithmic curves around a brilliant, golden heart. This grand design follows the same mathematical principles that govern nautilus shells, sunflower seed patterns, and hurricane formations. The golden spiral, a fundamental organizing principle woven into the fabric of nature at every scale from quantum to cosmic. Our galaxy possesses what astronomers call a barred spiral structure, meaning its central region extends into an elongated bar of stars approximately 27,000 light-years long. This central bar serves as more than mere decoration. It functions as a cosmic engine, rotating as a rigid structure and channeling matter inward from the outer regions, while simultaneously feeding material outward into the spiral arms. From this rotating bar emerge the galaxy's primary spiral arms, the Perseus arm sweeping beyond our solar system, the Sagittarius arm curving toward the galactic center, and our own Orion arm, the smaller spiral feature that serves as our cosmic neighborhood. Here lies one of astronomy's most elegant revelations. These spiral arms are not permanent structures like the spokes of a wheel, but rather traveling waves of density moving through the galactic disk. Think of them as cosmic traffic jams where stars and gas temporarily slow down and bunch together as they encounter regions of enhanced gravitational influence. Just as cars bunch up in slow-moving highway traffic while the traffic pattern itself remains stationary, stars flow into and out of the spiral arms while the arm pattern persists. This density wave mechanism creates the galaxy's most spectacular stellar nurseries. As gas clouds encounter a spiral arm, they become compressed by the increased gravitational field, triggering the collapse that ignites new generations of stars. These newborn stars, particularly the massive, brilliant blue giants, burn with intense luminosity that traces out the spiral structure in magnificent detail. Their brief, fierce lives, lasting only a few million years, mean they live and die largely within the spiral arms where they were born, creating that characteristic blue glow that defines the arm's leading edges. Behind these newborn stellar giants, you can trace an age gradient that tells the story of stellar evolution within the spiral structure. The youngest, hottest blue stars mark the arm's compressed leading edge, followed by slightly older stars that have begun to drift away from their birthplace. Further behind, the light settles into the warmer yellows and oranges of middle-aged stars like our Sun, creating the spiral arms' characteristic color progression from brilliant blue-white through golden yellow to the softer glows of stellar maturity. Our solar system's position within the Orion arm places us in a particularly stable galactic neighborhood. We orbit the galactic center approximately once every 230 million years, a span of time so vast that since complex life first emerged on Earth, our solar system has completed fewer than 3 full galactic orbits. This galactic year provides a profound measure of cosmic time. The entire recorded history of human civilization represents less than 1% of a single galactic rotation. We exist in what astronomers call the corotation region, where our orbital speed roughly matches the spiral pattern's rotation, meaning we neither catch up to nor fall behind the density waves, maintaining our position in this relatively calm stellar suburb. This stability has proven crucial for Earth's biological development, as it shields us from the intense radiation and frequent stellar explosions that characterize the galaxy's more active spiral arms, while still providing access to the heavy elements necessary for rocky planet formation. The spiral arms serve as the galaxy's primary recycling centers, where massive stars live brief, brilliant lives before exploding as supernovae, enriching the surrounding space with carbon, oxygen, silicon, iron, and other heavy elements essential for planets and life. The spiral structure extends far beyond the visible disk of stars, reaching deep into the galaxy's dark matter halo and connecting with vast streams of hydrogen gas that flow between the arms. These invisible currents, detectable through radio observations, reveal that the galaxy's spiral pattern influences matter distribution throughout the entire galactic system. The arms act as gravitational guides, channeling gas inward from outer regions and outward from the central bar, maintaining the delicate balance of matter flow that keeps our galaxy actively forming new stars. As you contemplate this hidden architecture, you begin to understand that the Milky Way operates as a living, breathing system where matter flows in great cycles spanning hundreds of millions of years. Gas condenses into stars within the spiral arms. Stars live out their nuclear life cycles and return enriched material to space, and this enriched material flows back into the spiral arms to form new generations of stars and planets. Every atom in your body has participated in this cosmic recycling process multiple times, having been forged in ancient stellar cores, scattered through space by stellar winds and supernova explosions, and eventually incorporated into the molecular cloud that gave birth to our solar system. The spiral arms create not just visible beauty, but also the galaxy's magnetic field structure, with magnetic field lines threading through space and helping to channel charged particles throughout the galactic disk. This magnetic architecture plays a crucial role in star formation, supporting or resisting gravitational collapse and influencing where new stars will be born. The interaction between magnetic fields, stellar winds, and supernova shockwaves creates a complex web of forces that shapes the galaxy's evolution across cosmic time. From your perspective within this grand spiral dance, you're witnessing billions of years of gravitational choreography, where attraction has sculpted matter into patterns of extraordinary beauty and complexity. The spiral arms that seem so permanent are actually ephemeral features, constantly forming and dissolving as density waves propagate through the galactic disk. Yet within this apparent impermanence lies deeper stability, as underlying gravitational forces continue organizing matter into new patterns of structure and beauty. Every breath you take contains atoms that have flowed through these spiral arms multiple times. Every heartbeat echoes the rhythm of stellar birth and death that powers galactic evolution, and every thought represents the universe's ongoing attempt to understand its own magnificent complexity through the consciousness it has created within these graceful spiral arms. As your awareness follows the spiral pattern inward, you sense how it naturally channels matter toward the galaxy's heart, where something even more profound awaits, a gravitational anchor so powerful it shapes the motion of hundreds of billions of stars while remaining forever hidden in darkness, following the spiral arms inward through their graceful gravitational choreography. You sense how their curves naturally tighten and converge, channeling matter toward an increasingly luminous heart. The starlight grows denser, warmer, transforming from the scattered jewels of the outer arms into a continuous golden glow that dominates the galactic core. Here, 26,000 light-years from our solar system, lies one of the universe's most profound mysteries. A gravitational colossus so powerful it shapes the motion of hundreds of billions of stars, yet remains forever hidden in absolute darkness. The galactic center appears as a brilliant bulge of ancient starlight, a crowded metropolis where suns pack together in numbers that defy imagination. From your earthbound perspective, this region blazes behind veils of interstellar dust so thick they obscure millions of stars from visible light. To pierce these cosmic curtains, astronomers must shift their vision beyond human sight, using infrared radiation to penetrate the dust, radio waves to trace magnetic fields, and X-rays to detect the signatures of extreme energy. Through these windows, the galaxy's hidden architecture emerges, revealing streams of gas spiraling inward, dense molecular clouds, and, most remarkably, stars moving at such extraordinary velocities that their very motion betrays the presence of something unimaginably massive yet invisible. There, at the precise gravitational center of our galaxy, lies Sagittarius A star, a supermassive black hole containing more than 4 million times the mass of our Sun, compressed into a region smaller than the orbit of Mercury. This is not merely an object, but a fundamental distortion in the fabric of space-time itself, where gravity has grown so intense that it bends light into impossible curves and stretches time into configurations that challenge human comprehension. You cannot see Sagittarius A star directly, for it emits no light of its own and reflects nothing back. Instead, it reveals itself through what it does to everything around it, like a deep well whose depth is measured not by sight but by the behavior of everything that falls toward its edge. The evidence for this invisible heart lies written in luminous calligraphy across the darkness, the precise orbital paths of stars that whip around the galactic center at velocities that humble earthly motion. Astronomers have patiently tracked these stellar dances for decades, watching them trace elliptical loops that bring them breathtakingly close to the central mass. Star S2, one of the most intensively studied objects in this extreme environment, completes its orbit in just 16 years, diving so close that it reaches speeds exceeding 7,000 kilometers per second, roughly 2% the speed of light itself. As this star sweeps past its closest approach, its light becomes subtly redshifted, time itself stretched by gravity's inexorable pull, providing quiet confirmation that space and time curve sharply in this region. These orbital measurements leave no room for alternative explanations. The concentration of mass at the galactic center must be what Einstein's equations predict: a region where the escape velocity exceeds the speed of light, creating an event horizon beyond which nothing can return to the outside universe. This boundary isn't a physical surface you could touch, but rather a point of no return in space-time geometry itself. For Sagittarius A star, this invisible sphere extends approximately 12 million miles from the central mass, creating a zone of absolute darkness at the heart of our galaxy's brilliant core. In 2022, humanity achieved something previously thought impossible, directly imaging the shadow of our galaxy's central black hole. Using a planet-sized network of radio telescopes working in perfect synchronization, the Event Horizon Telescope collaboration captured the first portrait of Sagittarius A star's silhouette, revealing a ring of incandescent matter surrounding the dark shadow of the event horizon. The light in this image comes not from the black hole itself, but from gas heated to billions of degrees as it spirals inward at nearly the speed of light, creating a brilliant accretion disk that illuminates the boundary between the visible universe and the realm beyond return. Yet despite its fearsome power, Sagittarius A star is remarkably gentle compared to the ravenous black holes that blaze as quasars in distant galaxies. Our galactic heart feeds quietly, occasionally swallowing a wandering gas cloud or unlucky star that drifts too close, releasing brief flares of energy that ripple through the surrounding space like cosmic sighs. These gentle outbursts remind you that even in the most extreme gravitational environment known to science, there exists a kind of patience, a rhythm measured in cosmic time rather than human urgency. The black hole's influence extends far beyond its immediate neighborhood through the organizing principle it provides for the entire galaxy. Without Sagittarius A star's central mass, the Milky Way might lack the gravitational anchor necessary to maintain its spiral structure across billions of years. The supermassive black hole doesn't dominate through force, but through presence, providing the stable reference point around which hundreds of billions of stars can pursue their ancient orbital dance. It serves as both memory and anchor, holding within its inescapable embrace the accumulated history of our galaxy's formation and evolution. If you could somehow approach the event horizon, the nature of reality itself would transform around you. Time dilation would become increasingly extreme, seconds stretching into minutes, minutes into hours from the perspective of distant observers. The light from surrounding stars would shift toward red as photons struggled to escape the intensifying gravitational field. Yet from your own reference frame, time would continue to flow normally even as you crossed the boundary into a realm where the familiar laws of physics encounter their ultimate test. The region immediately surrounding Sagittarius A star teems with phenomena that exist nowhere else in the galaxy. Massive stars follow highly elliptical orbits that precess slowly due to relativistic effects. their paths shifting slightly with each passage in precise agreement with Einstein's predictions. Magnetic field lines anchored in the accretion disk twist and reconnect, occasionally launching jets of particles at nearly the speed of light. The same fundamental physics that governs laboratory, plasmas and solar flares plays out here at energies and scales that dwarf anything found elsewhere in our cosmic neighborhood. Understanding how supermassive black holes form and grow remains one of astronomy's greatest puzzles. Sagittarius A star likely began as a much smaller black hole in the early universe, growing over billions of years by accreting surrounding matter and merging with other black holes as smaller galaxies were incorporated into the growing Milky Way. Each merger would have released tremendous energy in the form of gravitational waves, ripples in space-time itself that we've only recently learned to detect using incredibly sensitive instruments on Earth. The discovery that every large galaxy harbors a supermassive black hole at its center reveals these objects as fundamental components of cosmic architecture rather than cosmic accidents. The mass of each central black hole correlates surprisingly well with the mass of its host galaxy's central bulge, suggesting that black hole growth and galaxy formation represent intimately connected processes spanning cosmic history. As you contemplate this hidden gravitational heart, you begin to appreciate how the most extreme objects in the universe contribute to the delicate conditions that make life possible. Sagittarius A star's organizing influence helps maintain the stable galactic structure necessary for long-lived stellar systems like our own, regulating matter flow between different galactic regions and providing the gravitational framework within which planetary systems can develop the long-term stability required for complex chemistry and biological evolution. This invisible heart beats with a rhythm measured in cosmic time, its influence flowing outward through the spiral arms to touch every star, every world, every atom of your being, with the same ancient gravitational embrace that has guided our galaxy's evolution since the universe was young. This gravitational embrace that flows outward from Sagittarius, a star carries with it something far more profound than mere organizational force. It guides rivers of ancient light that tell the story of our galaxy's entire evolutionary history, written in starfire and time. As your awareness expands beyond the central black hole's immediate domain, the stellar landscape around you begins to reveal itself as a living archive, where each generation of stars carries the chemical signature of all those that came before, creating luminous currents that flow not just through space, but through the deep currents of cosmic time itself. The stars surrounding you exist in distinct populations that astronomers have learned to read like chapters in a cosmic biography, each layer telling its part of the Milky Way's 13 billion-year story. Closest to the galactic center, where Sagittarius A star's influence remains strongest, the stellar bulge glows with the warm light of ancient suns, predominantly red and orange giants that have burned steadily since the galaxy's turbulent youth. These elderly stars follow chaotic, elongated orbits that cross and scatter through the crowded core like rush-hour traffic in a cosmic metropolis, their paths preserving the memory of the violent mergers and gravitational encounters that assembled our galaxy from smaller building blocks scattered throughout the early universe. These ancient inhabitants, known as Population 2 stars, burn with the chemical simplicity of a younger cosmos. Their spectra reveal compositions dominated by hydrogen and helium, the primordial elements forged in the Big Bang's nuclear furnace, with only trace amounts of heavier elements that astronomers call metals, despite including familiar substances like carbon, oxygen, and iron. Each of these stellar elders serves as a fossil remnant of the galaxy's formation epoch, when the universe contained insufficient heavy elements to build rocky planets, complex chemistry, or biological systems. Their light represents rivers flowing across billions of years, carrying messages from an era when the cosmos was chemically innocent. before generations of stellar alchemy had enriched space with the ingredients of complexity. As you drift outward from the bulge into the galactic disk, the stellar architecture transforms dramatically, revealing the Milky Way's sophisticated layered structure. The thick disk, populated by moderately old stars with slightly puffed-up, tilted orbits, carries the memory of ancient turbulence, early heating events, and minor mergers that stirred stellar motions during the galaxy's more chaotic adolescence. Overlaying this is the thin disk, where younger stars pursue flatter, more circular paths in a dance of elegant precision that creates stable conditions for planetary systems to develop and maintain their delicate gravitational balance across billions of years. Within this thin disk, the galaxy's current stellar generation emerges continuously from vast molecular clouds, immense reservoirs of hydrogen, helium, and dust that drift like shadowed continents between the spiral arms. These stellar nurseries, often spanning hundreds of light-years, remain largely invisible to optical telescopes, appearing as dark patches against brighter stellar backgrounds. Yet within their frigid depths, gravity works with infinite patience, drawing atoms together into increasingly dense knots that will eventually ignite as new stars. The spiral density waves you explored earlier serve as the galaxy's primary mechanism for triggering this ongoing stellar birth. As molecular clouds encounter these gravitational compression zones, they fragment into smaller cores, each destined to become a star. The collapse accelerates as gravity overwhelms internal pressure, heating the infalling material until nuclear fusion finally ignites in the core, transforming gravitational potential energy into the sustained thermonuclear burning that will illuminate space for billions of years. This process creates the galaxy's most spectacular stellar nurseries, where hot, young, massive stars blaze with fierce blue-white intensity along the spiral arm's leading edges. These stellar giants, though living brief lives measured in mere millions of years, serve as the galaxy's alchemists, forging heavier elements, carbon, oxygen, nitrogen, iron, in their superheated cores through successive rounds of nuclear fusion. When they exhaust their fuel, they explode as supernovae in cosmic fireworks that briefly outshine entire galaxies, scattering their nuclear products across vast regions of space and enriching the interstellar medium with the building blocks of future complexity. This creates the galaxy's chemical evolution, a patient process of stellar recycling where each generation builds upon the nuclear achievements of its predecessors. The younger population-wise stars that inhabit the spiral arms, including our own Sun, formed from gas clouds already enriched with heavy elements from countless previous stellar life cycles. Their spectra reveal complex chemical signatures that make possible rocky planets, atmospheric chemistry, and ultimately the biological complexity that gave rise to consciousness itself. You can trace this chemical enrichment through the galaxy's metallicity gradient, where stars forming in the inner regions possess higher concentrations of heavy elements than those condensing in the outer spiral arms. This creates a kind of cosmic terroir where the chemical conditions available for planet formation vary systematically across the galaxy's architecture, influencing the types of worlds that can emerge in different galactic neighborhoods. The diversity of stellar types creates a temporal mosaic where ancient light mingles with radiation from stars born yesterday in cosmic terms. Red dwarf stars, small and cool, burn their nuclear fuel so efficiently they could continue fusion for hundreds of billions of years, longer than the current age of the universe. Yellow dwarfs, like our Sun, maintain steady burning for billions of years, providing the consistent energy necessary for complex life to evolve. Red giants and supergiants, having exhausted their core hydrogen, swell to immense sizes while gently shedding their outer layers into space, creating the beautiful planetary nebulae that mark a star's graceful transition to white dwarf. Retirement each type contributes its unique wavelength signature to the grand, rivers of photons that define the Milky Way's luminous architecture. The blue light of young, hot stars marks regions of active star formation, while the redder glow of older, cooler stars dominates the more settled, ancient populations. This interplay of color, brightness, and age paints a dynamic portrait of the galaxy's ongoing evolution, where light itself acts as a messenger, carrying information across both vast distances and unfathomable stretches of time. When photons from distant stars reach your eyes tonight, they carry with them fragments of history, memories of stellar birth, nuclear burning, and eventual death that began their journeys hundreds, thousands, or tens of thousands of years ago. You are not merely observing these rivers of ancient light as they were when that radiation began its trek across space. You are witnessing the galaxy's living memory, a cosmic library written in electromagnetic radiation where every glimmer tells part of its 13 billion-year narrative. This realization transforms your relationship with the night sky from passive observation to active participation in an ongoing cosmic story. Every element in your body heavier than hydrogen was forged in stellar cores and distributed through space by stellar winds and supernova explosions. The calcium strengthening your bones, the iron carrying oxygen through your bloodstream, the carbon forming the backbone of your DNA, all were created through stellar nucleosynthesis and scattered by stellar death, making you quite literally a temporary arrangement of stellar products that has achieved the remarkable ability to contemplate its own cosmic origins. The constant cycle of stellar birth and death ensures that the galaxy remains a dynamic, evolving system where cosmic recycling provides both the raw materials and the energy that make the universe a place of continuous creation. Between these brilliant stellar currents, however, lie vast regions that appear empty to casual observation, but contain the subtle matter that sculpts starlight itself, guiding photon paths and determining what reaches your awareness across the cosmic dark. Between these brilliant rivers of stellar light lies something far more subtle yet equally profound, a medium so seemingly transparent that it remained invisible to human awareness for centuries, yet so fundamentally important that it shapes every photon's journey across the galaxy and determines which ancient messages actually reach your consciousness through the cosmic dark. What appears to be empty space between the stars reveals itself, upon deeper contemplation, to be filled with an intricate canvas of dust and gas, so fine it makes terrestrial mist seem dense by comparison, yet so vast in its collective influence that it sculpts the very appearance of the Milky Way itself. This interstellar dust exists as an invisible artist, working with particles so small they defy imagination, each grain measuring roughly 1/10 of a micron across, smaller than the wavelength of visible light itself, tinier than the smallest motes of smoke that drift through earthly air. Yet together, these microscopic sculptors form immense clouds spanning hundreds of light years, containing enough material to birth thousands of new stars while remaining largely invisible to your direct perception. They work through the gentle art of absorption and scattering, preferentially removing blue light from stellar radiation while allowing longer, redder wavelengths to pass through relatively unimpeded. This selective filtering transforms the galaxy's true colors in ways both subtle and profound, making hot blue stars appear cooler and more golden when viewed through dusty veils, while creating the warm, amber hues that characterize the Milky Way's appearance from Earth. The dark lanes that seem to divide the galactic plane into segments aren't empty rifts torn in the stellar fabric, but rather dense concentrations of this cosmic dust, vast molecular clouds where temperatures drop to within a few degrees of absolute zero, and matter exists in forms so rarefied they approach the theoretical limits of nothingness. Each grain tells a remarkable story of stellar death and cosmic recycling. These particles began their existence in the atmospheres of dying stars, red giants that gently shed their outer layers into space, or the violent explosions of supernovae that scatter the products of stellar nucleosynthesis across interstellar distances. Carbon grains condense from the winds of carbon-rich stars. Silicate particles crystallize in oxygen-rich stellar atmospheres, and metallic cores form from the heaviest elements forged in stellar cores during their final moments before explosive transformation. Every speck of dust drifting between the stars carries within it the nuclear memory of some ancient sun that once burned brightly before returning its enriched matter to the cosmic medium as these particles drift through space across millions of years. They serve as microscopic surfaces where simple atoms can accumulate and combine into increasingly complex molecular structures. In the frigid depths of molecular clouds, hydrogen atoms slowly gather on grain surfaces and combine to form molecular hydrogen, the most abundant molecule in the universe. Water, ammonia, methanol, and even more sophisticated organic compounds build up as icy mantles around solid cores, creating microscopic chemical laboratories where the molecular ingredients necessary for life slowly accumulate in the darkness between stars. This process transforms the interstellar medium into a vast reservoir of prebiotic chemistry, where the building blocks of biological complexity develop long before planetary systems form. When gravitational collapse eventually transforms these dusty clouds into new stellar systems, the accumulated organic molecules become incorporated into forming worlds, seeding new planets with the chemical sophistication necessary for life's eventual emergence. Every breath you take contains water, molecules that likely spent millions of years frozen onto dust grains in the interstellar medium before becoming incorporated into Earth's oceans and atmosphere, the dark nebulae visible as shadows against brighter stellar backgrounds. The famous coal sack, the horsehead, the serpentine dark lanes that wind through Sagittarius represent regions where this cosmic dust has accumulated into dense enough concentrations to block visible light from more distant stars. Yet these apparent voids teem with invisible activity, as magnetic fields thread through the medium and guide the motion of charged particles, creating filamentary structures that stretch like cosmic spiderwebs between stellar neighborhoods. Perhaps most remarkably, this dust plays an essential role in enabling star formation itself. While blocking visible light, dust grains efficiently radiate away heat in the infrared, allowing molecular clouds to cool to the extremely low temperatures necessary for gravitational collapse to overcome thermal pressure. Without dust to facilitate this cooling process, star formation would be far less efficient, and the galaxy would remain a much emptier, darker realm. The very darkness of these nebulae becomes a prerequisite for the light of new stars, creating one of the universe's most beautiful paradoxes, that darkness enables illumination, that apparent emptiness nurtures creation. The interaction between starlight and dust creates some of the galaxy's most ethereal phenomena. Reflection nebulae glow with scattered blue light where nearby stars illuminate cosmic dust clouds, while emission nebulae shine in characteristic colors where stellar ultraviolet radiation ionizes surrounding gas. The subtle zodiacal light visible from dark locations on Earth results from sunlight reflecting off dust particles distributed throughout our solar system, connecting our local environment to the galaxy-wide processes of matter distribution and recycling. Even the magnetic fields threading through this interstellar medium play crucial roles in regulating galactic evolution. These invisible force lines, revealed through the polarization of starlight passing through aligned dust grains, create a hidden architecture that influences everything from individual star formation to the overall structure of spiral arms. The dust grains themselves, slightly elongated rather than perfectly spherical, tend to align with magnetic field directions, creating a subtle but detectable signature that allows astronomers to map the galaxy's magnetic skeleton. Understanding this invisible canvas fundamentally transforms your relationship with the night sky from passive observation to recognition of a complex, three-dimensional medium where light, matter, and magnetic fields interact in an ongoing dance of creation and transformation. The darkness between stars isn't empty, it's pregnant with possibility, filled with the raw materials and organizing forces that ensure the galaxy remains a dynamic, evolving system capable of creating new stars, new worlds, and potentially new forms of consciousness across cosmic time. This realization reveals the profound truth that what appears absent or empty often contains the greatest potential for creation. The dust that obscures distant starlight simultaneously provides the foundation for future illumination. The molecular clouds that seem to steal brightness from the sky are actually the reservoirs from which new brilliance will emerge. As your awareness moves through these seemingly quiet regions, you begin to sense the gathering tension where gravity slowly overcomes thermal resistance, where matter accumulates toward the critical densities that will soon transform darkness into the spectacular furnaces of stellar birth that await just beyond the threshold of visibility. Within these seemingly quiet reservoirs where cosmic dust has gathered across eons, something extraordinary begins to stir as gravitational forces finally reach the critical threshold where infinite patience transforms into purposeful action. The same molecular clouds that appeared so still and empty reveal themselves as cosmic wombs on the verge of birth, where the accumulated tension of millions of years suddenly accelerates into the galaxy's most spectacular creative events. These aren't voids, but vast nurseries pregnant with the promise of light, where the raw materials scattered by ancient stellar death are gathered and refined into the blazing furnaces that will illuminate space for billions of years to come. The transformation begins almost imperceptibly, as slight irregularities in density create gravitational seeds around which matter accumulates with increasing urgency. What started as gentle drift becomes purposeful infall as gravity overcomes the thermal motion that once held gas in equilibrium. Temperature paradoxically drops even as density increases, because those same dust grains that once blocked starlight now radiate heat away into space with ruthless efficiency, cooling the collapsing material to within a few degrees of absolute zero and removing the thermal pressure that might otherwise resist compression. As these stellar cocoons contract, they fragment into smaller cores, each destined to become an individual star. The process resembles a cosmic hierarchy of collapse, where vast clouds break into clusters, clusters divide into groups, and groups separate into dense knots that will eventually ignite as nuclear furnaces. Within each contracting core, temperature begins rising as gravitational potential energy converts to heat, creating the first faint glow of protostars still hidden within their dusty birthplaces, radiating warmth in infrared wavelengths that penetrate the veils invisible light cannot cross. Then, after hundreds of thousands of years of quiet gestation, a momentous threshold arrives. Deep within the protostar's core, temperature and pressure finally reach 10 million degrees Celsius, where hydrogen nuclei overcome their mutual electrical repulsion and begin fusing into helium. This moment of nuclear ignition marks not an explosion, but an awakening, as sustained thermonuclear fire begins the steady burning that will continue for millions or billions of years. The newborn star's radiation pressure finally balances gravitational infall, establishing the hydrostatic equilibrium that defines main sequence stellar life. Like a cosmic candle softly igniting within fog, yet powerful enough to illuminate vast regions of space. When these stellar infants finally clear away their dusty birth shrouds, the most massive among them burst forth as brilliant blue giants, burning with fierce intensity that dominates their surroundings. Their powerful ultraviolet radiation ionizes hydrogen across vast distances, creating the spectacular emission nebulae that rank among the universe's most beautiful phenomena. The Orion Nebula glows with characteristic red light of hydrogen recombination, where electrons cascade down energy levels and emit photons that travel across light years to reach your awareness. Within that luminous cavern, hot young stars flood the region with radiation, illuminating curtains and valleys of dust while their stellar winds carve intricate sculptures from the surrounding medium. These massive stellar sculptors work with tools of radiation pressure and supersonic winds, creating some of the galaxy's most dramatic landscapes. In the Eagle Nebula, towering pillars of creation rise like cosmic mountains, their dense tips sheltering new protostars while their edges slowly evaporate under intense stellar radiation. The Carina Nebula roars with hurricanes of energy from giant stars that carve pillars and arcs from surrounding gas, creating temporary masterpieces that will dissolve even as they reveal the next generation of stellar birth hidden within their shadows. This creates the galaxy's most elegant feedback mechanism, where stellar birth and death drive each other in continuous cycles of renewal. Supernova shock waves from dying massive stars compress nearby molecular clouds, triggering fresh episodes of gravitational collapse and star formation. Sequential star formation creates stellar associations, loose groups sharing common motion through space, preserving the memory of their collective birth in expanding bubbles of hot gas. For every massive blue giant that blazes briefly and dies dramatically, dozens of sun-like stars begin billion-year journeys, while hundreds of small red dwarfs ignite to burn steadily for hundreds of billions of years. Around many newborn stars, remaining dust and gas settles into circumstellar disks where planetary systems will eventually emerge. These protoplanetary disks show intricate structures where dust grains already clump together into building blocks of worlds, gaps indicating where planets may already be forming and clearing orbital paths through gravitational influence. The chemical composition reflects the galaxy's ongoing evolution, as each stellar generation forms from material enriched by previous life cycles, ensuring that heavy elements scattered by ancient supernovae enable formation of rocky planets capable of supporting complex chemistry. As your awareness expands through these active regions of stellar creation, you witness the galaxy's most fundamental process, transformation of potential into radiance, darkness into illumination, scattered matter into organized systems capable of warming worlds and nurturing consciousness. Every star that has ever shone, including the sun that enables your existence, emerged from such nurseries through the same patient accumulation of matter and sudden ignition of nuclear fire. The calcium in your bones, iron in your blood, carbon forming your DNA, all were forged in stellar cores and scattered by stellar winds and supernova explosions, making you literally a temporary arrangement of stellar products that has achieved the remarkable ability to contemplate its own cosmic origins. These sculptors of starlight work on timescales that dwarf human experience yet create the stable energy sources necessary for complex chemistry and biological evolution. The process continues throughout the galaxy at this very moment, ensuring the Milky Way remains a dynamic system where new illumination constantly emerges from cosmic darkness, guided by forces both visible and invisible that operate across scales spanning from quantum to cosmic, preparing to reveal the hidden architecture that holds this magnificent spiral dance together across billions of years. These magnificent sculptors of starlight, working their alchemy within vast molecular clouds and illuminating the spiral arms with brilliant blue fire, operate within a cosmic theater whose true architecture remains almost entirely hidden from view. As your awareness expands beyond these glowing nurseries where new stars burst into nuclear life, a profound realization begins to emerge through the subtle language of motion itself. The very stability that allows these stellar birth processes to continue across billions of years, the gravitational choreography that maintains the spiral arm's elegant curves, and the persistent rotation that has kept our galaxy intact since the universe was young, all depend upon a foundation that neither emits nor reflects a single photon of light. This invisible truth first revealed itself through one of astronomy's most puzzling discoveries. When astronomers carefully measured how fast stars orbit at different distances from the galactic center, they expected to find the same pattern that governs our solar system. Inner objects moving swiftly, outer ones moving slowly with orbital velocities decreasing predictably with distance. Instead, they discovered something extraordinary. Stars in the Milky Way's outer regions race around the galactic center at speeds that should have flung them into intergalactic space billions of years ago. Yet they remain gravitationally bound, tracing stable orbits that have persisted since before Earth formed its first oceans. The mathematics of this mystery proved inescapable. For these outer stars to maintain their observed velocities without escaping the galaxy's gravitational embrace, the Milky Way must contain approximately 5 times more matter than all the visible stars, gas, and dust combined. This additional mass reveals itself only through its gravitational influence, remaining completely invisible to every form of electromagnetic radiation, while providing the gravitational scaffolding that holds our galaxy together. Astronomers call this mysterious component dark matter, and it surrounds the luminous galaxy like an enormous, invisible cocoon extending hundreds of thousands of light-years beyond the farthest visible stars. Imagine the Milky Way's luminous disk as a brilliant whirlpool floating within a vast, transparent sphere of gravitational influence. This dark matter halo doesn't interact with light in any way. Photons pass through it as if it weren't there. Yet its gravitational embrace shapes every stellar orbit and determines the galaxy's fundamental structure. The spiral arms you've explored, the star-forming regions where new suns ignite, the ancient stellar populations carrying the galaxy's chemical memory all exist as luminous decorations on this invisible framework that extends far beyond what any telescope can directly observe. The evidence for this hidden architecture comes from multiple independent sources that paint a consistent picture of cosmic structure dominated by the unseen. Gravitational lensing reveals how dark matter bends the light from distant galaxies, creating subtle distortions that map the invisible mass distribution throughout the universe. Computer simulations of galaxy formation show that without dark matter's early gravitational head start, the universe would have remained a nearly uniform fog of hydrogen and helium, too smooth for ordinary matter to condense into the density contrasts necessary for star formation. In the early universe, long before the first stars ignited, dark matter began clustering into vast halos that served as gravitational wells within which ordinary matter could accumulate, cool, and eventually form the galaxies we observe today. Every galaxy exists within its own dark matter halo, and these halos connect across millions of light-years to form the cosmic web, a vast network of invisible filaments that provides the universe's fundamental architecture. The Milky Way sits within one node of this web where dark matter has accumulated over billions of years to create the gravitational foundation that enabled our galaxy's formation and continues to guide its evolution. What dark matter actually consists of remains one of science's most compelling mysteries. It might be composed of exotic particles that interact only through gravity, passing through ordinary matter without leaving any detectable trace. Laboratories. Deep underground conduct experiments designed to catch the faintest whisper of interaction between dark matter particles and ordinary atoms, while particle accelerators search for clues about the fundamental nature of this invisible component that comprises roughly 27% of the universe's total mass energy budget. This perspective transforms your understanding of cosmic architecture in profound ways. The familiar matter that forms stars, planets, and your own body represents less than 5% of the universe's total mass energy content, making the atoms and molecules of everyday experience a minority constituent in cosmic terms. The brilliant stellar nurseries, the spiral arms tracing their graceful curves, the supermassive black hole anchoring the galactic center, all exist within and depend upon this invisible ocean of dark matter that provides the gravitational stability necessary for complex structures to persist across cosmic time. The dark matter halo ensures that the Milky Way maintains its coherent structure over billions of years, protecting the galactic disk from disruptive encounters while gradually capturing smaller satellite galaxies and streams of gas that feed the ongoing cycles of star formation. When these captured systems are torn apart by tidal forces, they leave behind stellar streams that trace the dark matter's gravitational field as they wrap around the galaxy in complex loops and arcs, providing visible evidence of the invisible architecture that guides their motion. This hidden foundation profoundly shapes every aspect of galactic evolution, from the large-scale distribution of matter to the detailed chemistry that makes rocky planets and biological systems possible. The smooth, extended gravitational field provided by the dark matter halo protects our solar system's relatively calm orbit around the galactic center, ensuring the long-term stability necessary for complex life to develop on Earth. Every breath you take, every heartbeat, every thought occurs within this invisible embrace that has quietly held the universe together since shortly after the Big Bang. As you contemplate this revelation, the night sky transforms from a collection of visible objects to a window into a far grander, more mysterious cosmos, where the most fundamental organizing principles operate through invisible influence rather than luminous display. The darkness between stars isn't empty space, it's filled with the gravitational presence that makes starlight possible, the unseen scaffolding upon which all visible beauty depends. This invisible architecture extends its influence to the very edges of our galaxy, where ancient stars wander on elongated orbits through the dark matter halo's outer reaches, carrying within their light the chemical memories of the Milky Way's earliest epochs and serving as luminous breadcrumbs that trace pathways through the cosmic dark toward the quiet frontier where our galaxy's influence finally fades into the intergalactic void. Following these invisible pathways through the dark matter halo's vast transparent embrace, your awareness encounters something both ancient and profoundly solitary. Scattered points of light that wander far from the galaxy's luminous heart. On orbits so elongated and eccentric, they carry them hundreds of thousands of light-years from the crowded spiral arms where most stellar life unfolds. These are the halo stars, luminous breadcrumbs that trace the invisible architecture you've just explored, their lonely journeys mapping the true extent of the Milky Way's gravitational domain, while carrying within their nuclear hearts the chemical memories of epochs so remote they predate the formation of our solar system by billions of years. Unlike the orderly rotation of stars within the galactic disk, these cosmic wanderers follow chaotic, highly elliptical paths that plunge them deep into the galaxy's core before flinging them back out into the sparse regions where darkness dominates. And stellar encounters become events measured in geological time. Their orbits preserve the gravitational signatures of the violent processes that assembled our galaxy from smaller building blocks during the universe's more turbulent youth, when galactic cannibalism was common and the smooth spiral structure we observe today had yet to settle into its current elegant configuration. Each halo star moves like a pressure-supported particle in a vast swarm rather than following the carousel-like rotation of disk stars held together by the dark matter halo's broad gravitational field that you cannot see but can feel through their motion. When astronomers split their ancient light and read its spectral signature, these stellar elders reveal themselves as living fossils of cosmic archaeology. The oldest among them, known as Population 2 stars, formed when the universe contained almost no elements heavier than hydrogen and helium, making them natural laboratories where scientists can study the pristine composition of the early cosmos. Their atmospheres show metallicities thousands of times lower than our Sun's, indicating they condensed from gas clouds enriched by only the first few generations of massive stars, those primordial giants whose supernova explosions began the slow process of cosmic chemical evolution that would eventually make rocky planets and biological complexity possible. Many pulsars are our Lyrae variables, stellar metronomes that help astronomers measure distances across the galaxy's sparse outer regions like cosmic lighthouses marking safe passage through the dark. Perhaps most remarkably, many of these wanderers arrived in the Milky Way not as native-born citizens, but as refugees from smaller galaxies that were gravitationally captured and gradually torn apart by our galaxy's superior mass. The process of galactic accretion continues today, creating some of the most spectacular evidence for the dark matter halo's existence and structure. When these satellite systems are disrupted by tidal forces, they leave behind stellar streams that wrap around the Milky Way like luminous ribbons. Structures like the GD1 stream, the delicate filigree shed by Palomar 5, and the ongoing dissolution of the Sagittarius dwarf galaxy, whose stars now loop across the entire sky in great arcing trails that map the invisible gravitational field with exquisite precision. These stellar streams serve as gravitational fossils, preserving information about both the disrupted satellite galaxy and the dark matter distribution that captured and destroyed it. Computer simulations can reproduce their observed morphologies only when they include the gravitational influence of an extended dark matter halo, demonstrating how the unseen architecture shapes even the most distant stellar motions. Each stream represents a page torn from another galaxy's story and bound into ours, creating a living archive of mergers where the halo becomes a repository of cosmic encounters spanning billions of years. The sparse stellar density in these outer regions creates an environment profoundly different from the crowded galactic disk, where typical distances between neighboring stars stretch to hundreds or thousands of light years. If you could somehow visit a planetary system orbiting one of these ancient suns, the night sky would appear almost empty, a vast dark dome punctuated by only a few dozen visible stars, with the Milky Way's spiral disk appearing as a distant, faint glow on the horizon like a cosmic aurora. Yet even in this apparent isolation, these stars remain connected to the galaxy's larger story through invisible threads of dark matter that guide their motion and gravitational resonances that slowly evolve their orbits across cosmic time. Among these wanderers, an even more exotic population tears through space at astonishing velocities. Hypervelocity stars, some ejected by close encounters with Sagittarius A star in the galactic center, others flung by violent supernova explosions in binary systems, race through the halo on escape trajectories moving fast enough to leave the Milky Way entirely. These stellar outcasts will eventually become truly intergalactic wanderers, carrying with them samples of our galaxy's stellar population and potentially seeding the space between galaxies with heavy elements forged in stellar cores, serving as cosmic ambassadors to neighboring systems. As your awareness follows these stellar wanderers toward the very edge of the Milky Way's gravitational domain, the boundary between our galaxy and intergalactic space becomes increasingly ambiguous. The dark matter halo doesn't end abruptly, but gradually fades into the cosmic web's larger structure, creating a transition zone where the Milky Way's influence slowly yields to neighboring galaxies' gravitational pull. Around this frontier stretches a vast, tenuous atmosphere, the circumgalactic medium, a hot, ionized corona of gas heated to millions of degrees, too diffuse to see directly but revealed through its absorption signatures in ultraviolet and X-ray light from more distant objects. This coronal sea serves as both moat and reservoir, a place where outflows from supernovae in the disk mix with inflows from intergalactic filaments, where the galaxy exhales enriched material and inhales fresh hydrogen across cosmic time. Within this medium drift high-velocity clouds racing toward the disk and the titanic Magellanic Stream, a river of hydrogen torn from our satellite companions and stretched like gauze through the halo. These features aren't mere ornaments, but supply lines ensuring the Milky Way's star-forming factories receive the raw materials necessary for continued stellar birth across billions of years. Even here at the apparent edge of everything familiar, you sense how the galaxy breathes through this frontier, its circulation systems extending far beyond the visible stars into realms where matter flows in great cycles spanning hundreds of millions of years. The halo stars serve as witnesses to this cosmic metabolism, their ancient orbits carrying them through the full range of galactic environments, while preserving within their light the chemical and dynamical memory of epochs when the universe was young and the fundamental architecture of large-scale structure was still taking shape. Their journeys prepare your awareness for the next phase of exploration, where the boundaries between galaxy and cosmos dissolve entirely, revealing the vast streams of hydrogen that nourish the ongoing cycles of creation flowing invisibly between the stars, these ancient wanderers, tracing their eccentric paths through the dark matter halo, reveals something far more profound than stellar archaeology. They serve as luminous markers for invisible rivers that flow through the galaxy's vast spaces, carrying the universe's most abundant element in currents so subtle they remained hidden from human awareness until radio telescopes learned to listen for their whispered signature. Beyond the sparse realm where halo stars drift in solitary majesty, your awareness encounters the Milky Way's true circulatory system, streams of neutral hydrogen that form the galaxy's lifeblood, sustaining the cycles of stellar birth and death that have illuminated space for over 13 billion years. This hydrogen carries within its atomic structure the memory of creation itself, born in the first few minutes after the Big Bang. When the universe was a searing plasma of protons and electrons, these simple atoms have journeyed across cosmic time largely unchanged, waiting for gravity's patient gathering to transform them into the raw material for stars, planets, and ultimately consciousness. Each hydrogen atom consists of nothing more than a single proton orbited by a single electron. Yet from this fundamental simplicity emerges all the complexity you observe throughout the cosmic web. The calcium in your bones, the iron in your blood, the carbon forming your DNA, all began as hydrogen in stellar cores before nuclear fusion transformed simplicity into diversity. The revelation of this invisible architecture came through one of nature's most subtle quantum events. Occasionally, roughly once every 11 million years, a hydrogen atom's electron spontaneously flips its spin state, releasing a faint whisper of energy as a radio wave precisely 21 centimeters long. This hyperfine transition creates the universe's most persistent radio beacon, allowing astronomers to map hydrogen's distribution and motion throughout the galaxy with exquisite precision. When radio telescopes tune to this frequency, they reveal the Milky Way wrapped in delicate filaments of gas, spiraling outward from the core like luminous veins carrying the raw materials of creation through the galaxy's extended body. Through this radio vision, the galaxy transforms from a collection of luminous objects into recognition of a breathing, metabolizing organism where matter circulates in great cycles spanning hundreds of millions of years. Fresh hydrogen streams inward from the intergalactic medium, drawn by the galaxy's gravitational embrace and guided along magnetic field lines that thread through space like invisible highways. This pristine material, chemically unchanged since the primordial nucleosynthesis, provides the fuel that stellar nurseries transform into new generations of suns while simultaneously carrying the accumulated heavy elements scattered by previous stellar life cycles back into the cosmic recycling process. The galaxy inhales through vast streams flowing inward from the cosmic web's filamentary structure, where high-velocity clouds race toward the galactic disk at speeds indicating their origin beyond our gravitational system. These compact hydrogen concentrations represent fragments of the larger cosmic architecture being captured and incorporated into the Milky Way's ongoing evolution. When they collide with the established galactic structure, they trigger bursts of star formation while adding their mass to the galaxy's fuel reserves, demonstrating how cosmic-scale processes directly influence local stellar birth rates across vast distances and timescales. Perhaps most dramatically, the Magellanic Stream stretches across more than 100 degrees of sky as a titanic river of hydrogen torn from our satellite companions by tidal forces and ram pressure as they orbit through the Milky Way's extended atmosphere. This colossal structure, invisible to optical observation yet prominent in radio maps, contains enough material to fuel star formation for billions of years while providing a real-time demonstration of galactic cannibalism, where larger systems sustain themselves by gradually consuming their smaller neighbors and transforming their raw materials into renewed stellar activity. The galaxy also exhales, creating sophisticated feedback mechanisms that regulate its long-term evolution. Stellar winds from massive young stars and violent shockwaves from supernova explosions drive enriched gas outward from star-forming regions, creating galactic fountains that carry heavy elements forged in stellar cores far above the galactic disk before gravity eventually draws them back down to mix with incoming flows. This creates a multi-phase interstellar medium where hot, ionized gas in the million-degree corona mingles with warm, neutral regions and cold molecular clouds, each phase playing essential roles in the galaxy's metabolic processes. Magnetic fields threading through these hydrogen flows provide crucial regulation by controlling how matter moves between different galactic regions and how efficiently star formation proceeds within molecular clouds. These invisible force lines create a hidden architecture that guides charged particles along preferred pathways while resisting motion perpendicular to field directions, resulting in a galaxy-spanning magnetic web that channels inflowing material towards star-forming regions while supporting the outflows that carry stellar feedback energy to larger scales. Within the galactic disk, hydrogen flows trace the spiral density waves that organize star formation into elegant arm structures, revealing how matter moves between arms during each orbit around the galactic center. The gas responds dynamically to gravitational perturbations, magnetic forces, and pressure gradients, creating a rich tapestry of motion that connects different galactic regions in ongoing exchanges of matter and energy. Where these streams intersect and compress, molecular clouds gather toward the critical densities that will ignite new stellar nurseries, ensuring that galactic evolution proceeds as a continuous process rather than discrete episodes. This metabolic perspective reveals your intimate connection to these invisible cosmic currents. Every atom of hydrogen in your body has participated in this galactic circulation, having been processed through stellar cores, dispersed by stellar winds mixed in the interstellar medium, and eventually incorporated into the molecular cloud that gave birth to our solar system. The water molecules flowing through your cells likely condensed on dust grains in dark clouds before the sun formed, traveled as ice through the protoplanetary disk, and rained onto Earth from comets carrying the galaxy's chemical memory across billions of years of cosmic evolution. As these hydrogen streams flow inward toward the spiral arms, they begin to fragment and compress, their edges glowing faintly as they approach regions of enhanced stellar activity. The silence here transforms from emptiness to anticipation, carrying the quiet tension of matter gathering toward the densities that will soon burst into nuclear fire. This galactic breathing ensures that the Milky Way remains a vibrant, evolving system, always renewing itself through the circulation of the universe's simplest element while preparing for its next encounters with the luminous companions whose gravitational influence shapes these very flows across the cosmic distances that separate our galaxy from its nearest neighbors in the vast archipelago of the local group. These vast hydrogen streams that nourish the Milky Way's stellar nurseries do not arise from the empty void alone, but flow from gravitational encounters playing out across hundreds of thousands of light years, where our galaxy's invisible embrace slowly captures and transforms smaller stellar systems in an ancient dance of attraction that reveals itself most dramatically in the southern skies of Earth, following the radio whispers of neutral hydrogen backward through space. Your awareness encounters the luminous sources of these cosmic rivers, irregular galaxies that shine like ethereal companions against the darkness, bound to our spiral home by the same gravitational forces that guide every stellar orbit and shape every molecular cloud within the galactic disk, the large and small. Magellanic clouds appear from Earth's southern hemisphere as detached wisps of the Milky Way itself, soft patches of light that ancient navigators used to guide their journeys across terrestrial oceans. Yet from your expanded cosmic perspective, these companions reveal themselves as dynamic galaxies in their own right, each containing billions of stars locked in an intricate gravitational waltz that has continued for billions of years. The large Magellanic Cloud blazes with the irregular brilliance of active creation, a stellar metropolis roughly one-tenth the Milky Way's mass, yet burning with youthful intensity that outshines anything found within our galaxy's current spiral arms. Within the large cloud's chaotic architecture lies one of the local universe's most spectacular stellar nurseries, the Tarantula Nebula, a cosmic foundry so vast and energetic it spans nearly 1,000 light-years while radiating with the combined power of millions of suns. Here, massive blue giants crowd together in clusters so dense their gravitational interactions fling some stars into intergalactic space, while their fierce ultraviolet radiation ionizes immense caverns of hydrogen, painting the surrounding gas in brilliant hues of violet and rose that speak of nuclear fire unleashed on scales that dwarf terrestrial comprehension. These stellar giants live fast and die spectacularly, their supernova explosions enriching the cloud's interstellar medium with heavy elements, while demonstrating how galactic chemical evolution proceeds through cycles of stellar birth and death. The small Magellanic Cloud drifts at a greater distance, its form stretched and distorted by the gravitational tug-of-war between its larger companion and the Milky Way's overwhelming mass. This smaller system glows with the redder light of older stellar populations, its star formation largely quenched by the same tidal forces that have elongated its structure into an asymmetric smear of ancient starlight. Together, these companions create a gravitational, binary system whose orbital dance generates some of the most dramatic large-scale structures visible in radio. Astronomy, vast streams of hydrogen torn from their outer regions and stretched across hundreds of thousands of light-years of space. The most spectacular manifestation of this interaction flows as the Magellanic Stream, a titanic river of neutral hydrogen that arcs across more than 200 degrees of sky, stretching from the cloud's current position to wrap entirely around the Milky Way's southern hemisphere. This colossal structure, invisible to optical telescopes yet prominent in 21-centimeter radio observations, represents one of the largest coherent features in our galactic neighborhood, a demonstration of how tidal forces and ram pressure can strip material from smaller galaxies and transform it into the fuel for future stellar generations. As the Magellanic Clouds orbit through the Milky Way's extended corona, their gas encounters the million-degree plasma of our galaxy's circumgalactic medium, creating bow shocks and turbulent wakes that heat and compress the stripped material, while guiding its inward flow toward regions where it will eventually trigger new episodes of star formation. Beyond these prominent companions, dozens of smaller satellite galaxies trace the three-dimensional structure of the Milky Way's dark matter halo while preserving fossil records of cosmic evolution spanning billions of years. Ultra-faint dwarf systems like Segway 1 and Boötes contain fewer than 1,000 stars each, yet their very existence provides crucial evidence for dark matter's role in cosmic structure formation. These ancient stellar populations formed before significant heavy element enrichment had occurred, making them natural laboratories for studying the universe's primordial chemical composition and the earliest phases of galaxy assembly. The ongoing disruption of the Sagittarius dwarf elliptical galaxy provides a real-time demonstration of galactic cannibalism in action as this system slowly dissolves during its passage through the Milky Way's disk, leaving behind stellar streams that loop entirely around the sky while gradually incorporating its ancient stars into our galaxy's halo population. This process of hierarchical assembly represents the fundamental mechanism through which large galaxies grow over cosmic time, accumulating mass and stellar populations through countless minor mergers while preserving the dynamical and chemical signatures of their building blocks within complex kinematic structures that astronomers are only beginning to understand. Each satellite system contributes its unique gravitational influence to the Milky Way's overall architecture, creating perturbations that propagate through the galactic disk as density waves capable of triggering star formation while simultaneously providing observational evidence for the extended dark matter distribution that binds the entire system together. The orbital properties and internal dynamics of these companions can only be explained through interactions with vast, invisible halos that outweigh their visible stars by factors of hundreds or thousands, demonstrating how cosmic structure depends fundamentally upon the unseen scaffolding of dark matter that guides galactic evolution across billions of years. This recognition transforms your understanding of galactic ecology from isolated stellar systems to interconnected networks, where matter flows continuously between different components through gravitational interactions spanning millions of light years. The hydrogen streaming inward from disrupted satellites mixes with gas expelled by stellar winds and supernova explosions, creating a complex multi-phase medium where the galaxy breathes through cycles of accretion and feedback that regulate star formation rates while determining the chemical evolution that makes rocky planets and biological complexity possible. Every atom of calcium strengthening your bones, every molecule of iron carrying oxygen through your bloodstream, every carbon backbone supporting your DNA has participated in these grand cycles of galactic metabolism, having been processed through stellar cores, scattered by stellar winds mixed in the interstellar medium, and eventually incorporated into the molecular cloud that gave birth to our solar system. The dancing companions that illuminate the southern skies are not distant objects, but intimate participants in the cosmic recycling processes that created the very elements from which your consciousness emerges to contemplate their ancient light as these satellite systems continue their patient orbits, gradually surrendering their mass to feed the Milky Way's ongoing evolution. They prepare the stage for an even more dramatic gravitational encounter approaching across the cosmic distances that separate our galaxy from its largest neighbor in the local group, where another spiral system races toward us through the expanding universe with enough mass and momentum to reshape everything you've explored into entirely new configurations of matter, energy, and possibility. These gravitational streams flowing from our dancing companions represent merely the opening notes of a far grander cosmic symphony, one whose crescendo approaches across the vast intergalactic distances with such inexorable patience that its ultimate expression will reshape everything you've explored into entirely new configurations of stellar architecture. Beyond the Magellanic Cloud's luminous arcs, beyond the dissolving streams of captured dwarf galaxies, your awareness encounters the approaching presence of our cosmic twin, a spiral galaxy so massive and magnificent that its eventual gravitational embrace will transform both systems into something unprecedented in their shared evolutionary history. The Andromeda Galaxy blazes across 2.5 million light-years of intergalactic space with nearly twice the Milky Way's mass. Its trillion stars arranged in spiral arms that mirror our own, yet burn with the slightly bluer radiance of a more chemically evolved stellar population. When you glimpse that faint smudge of ancient light in Earth's northern sky, you're witnessing photons that began their journey before human ancestors discovered fire, carrying across the cosmic void the integrated glow of hundreds of billions of suns arranged in gravitational harmony. Yet this ethereal apparition represents not a static monument to cosmic architecture, but a dynamic system racing toward us at over 250 kilometers per second, its blue-shifted spectrum revealing approach velocities that speak of inevitable collision across the next 4.5 billion years. This approaching waltz has been choreographed across the entire 13 billion year history of the local group, as dark matter halos that condensed shortly after the Big Bang have slowly overcome the universe's expansion through their mutual gravitational attraction. Computer simulations reveal how these invisible realms of influence have been drawing the galaxies together across cosmic time, their approach initially slowed by cosmic expansion, but now accelerating as they fall deeper into each other's gravitational potential wells. The encounter timeline stretches across such vast duration that it encompasses the Sun's entire remaining main sequence lifetime, from its current middle age through its red giant transformation and eventual white dwarf retirement. When these galactic titans finally meet, their encounter will unfold not as catastrophic collision, but as an elegant gravitational ballet performed across hundreds of millions of years. The first contact occurs between their extended dark matter halos, vast invisible cocoons that will interpenetrate and merge long before the luminous disks begin to interact directly. As the galaxies approach within several 100,000 light-years, tidal forces will begin their patient work of transformation, drawing out spectacular streams of stars that arc between the approaching cores like luminous bridges spanning the cosmic void. From any world that might witness this cosmic theatre, the night sky will become a cathedral of impossible beauty. Andromeda will swell across the heavens, its majestic spiral arms clearly visible to the naked eye, while tidal streams create temporary constellations that trace the gravitational artistry of merging galaxies. These stellar rivers will flow like liquid light between the systems, carrying within their luminous currents the chemical heritage of both galaxies while preparing the raw materials for unprecedented bursts of stellar creation. The remarkable aspect of this collision lies in the vast emptiness between individual stars that makes direct impacts vanishingly rare. Even when the galactic disks interpenetrate completely, typical stellar separations exceed stellar diameters by factors of millions, ensuring that our Sun's probability of colliding with another star remains negligible across human comprehension. Instead, the encounter reshapes both galaxies through gravitational forces alone, scrambling stellar orbits while compressing molecular clouds into the dense configurations that trigger spectacular episodes of star formation throughout the merging systems. Multiple passages characterize this cosmic dance. As the galaxies swing past each other in ever-tightening orbits, each encounter stripping away more material while depositing gravitational energy into increasingly chaotic stellar motions. The first pass may occur in roughly 4 billion years, followed by a second major encounter as orbital decay brings the systems back together with even greater violence. Through each passage, spiral structures dissolve and reform, while shock waves propagating through compressed gas trigger starbursts that briefly increase stellar birth rates by factors of 10 or more, consuming molecular cloud reservoirs at unsustainable rates while painting space with the brilliant blues and ultraviolets of massive young stars living brief, spectacular lives. At the heart of this transformation, The supermassive black holes anchoring each galactic center will trace their own dramatic orbital decay as dynamical friction gradually removes energy from their motion. Sagittarius A star, with its 4 million solar masses, will spiral inward toward Andromeda's even more massive central giant, containing over 100 million solar masses, and until they eventually coalesce in a burst of gravitational waves powerful enough to shake the fabric of space-time itself. This black hole merger will create one of the most energetic events possible in the universe, briefly radiating more power in gravitational waves than all visible stars combined emit in electromagnetic radiation. The ultimate outcome of this merger will be the formation of Milky Way, a massive elliptical galaxy whose smooth, featureless morphology will glow with the combined light of both progenitor systems while exhibiting the gravitational equilibrium typical of systems formed through major mergers. The elegant spiral structures that once defined both galaxies will have dissolved into a more diffuse stellar distribution, their gas largely consumed in preceding starbursts or heated beyond easy condensation by the collision's energetic feedback processes. Throughout this transformation, the fundamental cycles of stellar birth and death continue, though dramatically altered by the merger's effects. The heavy elements forged in stellar cores and scattered by supernova explosions become incorporated into the interstellar medium of the merged system, making Milky Way more chemically complex and potentially more hospitable to rocky planet formation than either of its progenitors. Every atom of calcium strengthening your bones, every molecule of iron carrying oxygen through your bloodstream, every carbon backbone supporting your DNA will participate in this cosmic recycling, contributing to the chemical enrichment that ensures the universe becomes increasingly sophisticated across cosmic time. This approaching collision represents the natural culmination of structure formation processes that began with tiny density fluctuations in the early universe, demonstrating how gravitational amplification transforms microscopic quantum variations into the cosmic web of dark matter filaments and nodes that provide scaffolding for all large-scale architecture. The local group itself formed as matter accumulated within one such node, creating the gravitational environment where multiple galaxies could evolve while remaining bound by their mutual attraction across billions of years. As this inevitable future approaches with the patience of cosmic time, you begin to sense how even the most stable galactic structures exist within dynamic networks of gravitational interaction that connect individual systems across the vast spaces between them, preparing your awareness for the recognition that galaxies themselves are merely luminous nodes within an even grander architecture that spans the observable universe through invisible bridges of matter and energy. These gravitational streams orchestrating the inevitable collision between galactic titans reveal something far more profound than isolated cosmic encounters. They flow through a medium so subtle it remained invisible to human awareness for millennia, yet so vast in its collective influence that it contains more ordinary matter than all the visible stars and galaxies combined. As your awareness expands beyond the local group's familiar architecture, the apparent emptiness separating Andromeda from the Milky Way across 2.5 million light-years transforms into recognition of invisible bridges that have been guiding cosmic evolution since the universe first began cooling from its primordial fire, connecting every galactic system through networks so tenuous they approach the theoretical limits of nothingness, yet span the observable cosmos. This intergalactic medium exists at densities that humble even laboratory vacuums, perhaps one proton drifting alone through each cubic meter of space, making the thin air atop Earth's highest mountains seem impossibly dense by comparison. Yet across the millions of light-years separating neighboring galaxies, this seemingly negligible presence accumulates into a cosmic ocean whose influence shapes galactic evolution through processes so gradual they unfold across billions, of years, while profoundly determining which systems will thrive, merge, or fade into cosmic darkness. The space between galaxies isn't empty, it's pregnant with the universe's most patient circulation patterns, where matter flows in currents measured not in terrestrial time, but in the deep rhythms of cosmic expansion and gravitational attraction. The revelation of this hidden architecture emerged through humanity's most ingenious observational techniques, as astronomers learned to read the shadows cast by invisible gas clouds upon the light of distant quasars. When radiation from these brilliant galactic cores traverses billions of light-years to reach our telescopes, it encounters countless intervening hydrogen clouds that imprint their chemical signatures through subtle absorption lines, creating what scientists call the Lyman alpha forest, a woodland of spectral shadows that maps the large-scale structure of matter distributed throughout cosmic space. Each absorption line marks a filament, a gentle concentration of gas flowing under gravity's guidance, revealing how the apparent void between galaxies actually teems with invisible architecture, connecting every luminous system to its neighbors. Between the Milky Way and Andromeda, this tenuous medium plays crucial roles in preparing their eventual merger through interactions that began billions of years before their visible components will directly encounter each other. Hot coronal gas heated to millions of degrees by supernova explosions and stellar winds creates vast atmospheric halos extending hundreds of thousands of light-years beyond each galaxy's visible boundaries, forming overlapping zones where matter exchanges between systems through ram pressure effects and magnetic field interactions that create turbulent mixing regions where enriched material dispersed by ancient stellar death mingles with pristine hydrogen accreting from the cosmic web's larger circulation patterns. These galactic atmospheres don't simply exist in isolation, but actively communicate across intergalactic distances through processes that demonstrate how cosmic evolution operates as a unified system rather than separate events. High-velocity clouds racing through this medium carry chemical signatures, revealing their origins in tidal interactions that occurred millions of years ago, while hypervelocity stars ejected by close encounters with supermassive black holes traverse the intergalactic gap as stellar ambassadors carrying samples of their parent galaxy's stellar populations toward eventual incorporation into neighboring systems. Even the magnetic fields threading through this space, though incredibly weak by terrestrial standards, create invisible highways that guide charged particle motion across cosmic distances while influencing how matter flows between different galactic regions during ongoing cosmic evolution. The chemistry of the intergalactic medium tells the remarkable story of cosmic enrichment, as elements forged in stellar cores and scattered by supernova explosions gradually mix throughout space rather than remaining confined to their stellar birthplaces. Oxygen, carbon, nitrogen, and iron detected through absorption against distant quasar light reveal how galactic winds have transported the products of stellar evolution far beyond their parent systems, creating universe-wide circulation where heavy elements essential for rocky planet formation and biological chemistry become available throughout cosmic space. Every atom of calcium strengthening your bones, every molecule of iron carrying oxygen through your bloodstream, every carbon backbone supporting your DNA has likely traveled through intergalactic space multiple times during its cosmic journey, having been processed through stellar cores in distant galaxies before eventually becoming incorporated into the molecular cloud that gave birth to our solar system. This perspective fundamentally transforms understanding of galactic evolution from isolated island universes to interconnected ecosystems where matter, energy, and information flow continuously between systems through invisible networks that operate across scales spanning from stellar neighborhoods to the cosmic web's largest filaments. Galaxies breathe through this medium, inhaling fresh hydrogen to fuel star formation, while exhaling enriched gas that seeds space with the chemical complexity necessary for future generations of worlds and potentially consciousness itself. The approaching Andromeda collision represents merely one dramatic manifestation of gravitational processes that connect every cosmic structure through patient attraction operating across billions of years. Dark matter provides the invisible scaffolding that organizes these flows, creating overlapping halos that extend far beyond visible galactic boundaries, while guiding ordinary matter's motion through gravitational influence that remains completely transparent to electromagnetic radiation. Computer simulations reveal how these invisible structures interact through gravitational forces alone, demonstrating that the cosmic web's filamentary architecture emerged from tiny density fluctuations in the early universe that gravity has been amplifying across cosmic time into the magnificent network of matter and energy that provides the framework within which galaxies, stars, and consciousness can emerge to contemplate their own origins. As your awareness follows these invisible currents beyond the local group's boundaries, you begin to sense how individual galactic encounters like our approaching merger with Andromeda represent local manifestations of far grander patterns that extend throughout the observable universe, preparing to reveal the cosmic web's full majesty, where these intergalactic bridges coalesce into luminous networks spanning billions of light-years, while demonstrating how gravitational attraction has transformed the universe from primordial smoothness into hierarchical structures of breathtaking complexity and beauty. These invisible bridges connecting neighboring galaxies through the tenuous intergalactic medium reveal themselves as merely the finest capillaries of a circulatory system so vast and intricate it encompasses the entire observable universe, transforming what once appeared as cosmic emptiness into recognition of the most magnificent architecture ever discovered. As your awareness expands beyond the local group's familiar gravitational encounters, the perspective shifts dramatically from individual galactic streams to the breathtaking realization that galaxies themselves exist as luminous pearls strung along invisible threads spanning hundreds of millions of light-years, creating a three-dimensional web of such delicate beauty and mathematical precision that it resembles neural pathways in some vast cosmic mind. This is the cosmic web, the universe's fundamental skeleton, where matter flows along preferred pathways carved by gravity from the earliest moments of cosmic history. What appears as random scattering of galaxies across the night sky actually follows profound organizational principles, with stellar systems congregating along slender filaments that stretch between massive nodes where thousands of galaxies gather in gravitationally bound clusters, while vast voids expand between these luminous highways like cosmic bubbles in an infinite foam. The pattern emerges with stunning clarity when astronomers map millions of galaxy positions across cosmic distances, revealing a lacework of light and shadow that speaks of deep order arising from apparent chaos. The cosmic web's architecture emerged from the universe's most subtle beginnings when quantum fluctuations during the primordial expansion created tiny variations in matter density, differences so small they represented mere parts in 100,000 yet contained within them the seeds of every structure you observe today. Gravity, working with infinite patience across billions of years, amplified these microscopic irregularities through processes of extraordinary elegance, drawing matter toward regions of slightly enhanced density, while the spaces between them became increasingly empty as their contents migrated toward these gathering centers. Dark matter provided the invisible scaffolding that made this transformation possible, its particles interacting only through gravity, yet creating the gravitational wells within which ordinary hydrogen and helium could accumulate and eventually condense into the first stars. Computer simulations reveal how this process unfolds through purely gravitational dynamics. As dark matter halos collapse into filamentary networks that guide ordinary matter's behavior across cosmic scales, ensuring that the universe evolved. From nearly perfect smoothness into the magnificent tapestry of cosmic architecture where consciousness can emerge to contemplate its own origins. At the web's intersection points, galaxy clusters blaze as cosmic cities containing thousands of individual systems bound together by gravitational forces so intense they create some of the universe's most extreme environments. The Coma Cluster burns with X-ray radiation from gas heated to 100 million degrees by gravitational compression, while the nearby Virgo Cluster demonstrates how these massive structures influence their surroundings across tens of millions of light years, through gravitational attraction that shapes every neighboring galaxy's motion and evolution. Our local group occupies one modest node within a much larger gravitational basin called the Laniakea Supercluster, whose name means immeasurable heaven in Hawaiian, a fitting designation for a structure spanning over 500 million light-years and containing more than 100,000 galaxies, all flowing toward a common center of mass. Within this vast watershed, the Milky Way and Andromeda participate in gentle currents that have been carrying them toward their eventual collision across billions of years. Their approach representing just one local manifestation of the cosmic web's ongoing evolution as matter continues streaming along filaments established shortly after the Big Bang. Between the luminous filaments stretch cosmic voids, immense regions containing remarkably few galaxies yet spanning hundreds of millions of light-years, with matter densities approaching theoretical minimums for an expanding universe. These apparent empty spaces aren't truly vacant, but contain the web's supporting architecture, with dark matter creating gentle gravitational gradients that guide matter flow toward the filaments, while magnetic fields threading through the void influence cosmic ray propagation and the large-scale organization of intergalactic space. The web's influence extends far beyond mere matter distribution, determining where stars can form efficiently, where heavy elements become available for rocky planet formation, and ultimately where the chemical and energetic conditions necessary for life can develop across cosmic time. Galaxies forming within dense filaments experience enhanced merger rates and more active star formation, while those inhabiting void regions evolve more slowly and may struggle to maintain the stellar birth rates necessary for ongoing chemical enrichment. This recognition transforms your understanding of existence from isolated planetary life to participation in a vast, interconnected network where every atom in your body has traveled along these cosmic highways multiple times during its journey from primordial nucleosynthesis through stellar cores and eventually into the molecular clouds that gave birth to our solar system. The calcium strengthening your bones, the iron carrying oxygen through your bloodstream, the carbon forming your DNA. All have flowed through these invisible filaments across billions of years, making you quite literally a temporary arrangement of cosmic web material that has achieved the remarkable ability to contemplate the architecture that created and sustains it. Even the cosmic web's characteristic scale preserves memory of the universe's earliest moments, as baryon acoustic oscillations, frozen sound waves from when matter and radiation moved together in the primordial plasma, appear as preferred separations between galaxies, creating subtle ripples in large-scale structure that serve as standard rulers for measuring cosmic distances and confirming that this magnificent architecture retains the blueprint drafted when the universe was still, opaque to light, as this grand structure continues its slow evolution across cosmic time, with filaments growing denser while voids expand ever larger. You begin to sense how even this largest scale of organization exists within something even more profound, the expanding space-time itself that carries the entire web outward while preserving the delicate balance between gravitational attraction and cosmic expansion. Following these filaments backward through time toward their ultimate origin, your awareness approaches the moment when this invisible architecture first began forming, preparing to encounter the ancient afterglow that still bathes the cosmos from every direction, carrying within its subtle variations the initial conditions that would eventually bloom into the cosmic web's magnificent complexity. Following these cosmic filaments, backward through time toward their ultimate origin, your awareness encounters something extraordinary. The moment when the invisible architecture you've been exploring first began to take shape, preserved forever as a gentle whisper of ancient light that bathes every corner of space with the afterglow of creation itself. This faint glow arrives from every direction simultaneously, so uniform it seems like cosmic silence made visible, yet carrying within its subtle variations the complete blueprint for everything that would follow. Every galaxy, every star, every breath you've ever taken, all encoded in temperature fluctuations so delicate they represent mere parts in 100,000, yet contain the seeds of infinite complexity. This is the cosmic microwave background, the oldest light you can ever hope to observe. The fossilized echo of the moment when the universe first became transparent to electromagnetic radiation. At just 2.725 degrees above absolute zero, this ancient glow fills every cubic centimeter of space with roughly 400 photons carrying the direct memory of creation. Stretched and cooled by nearly 14 billion years of cosmic expansion from what was once a blazing fire hot enough to prevent atoms themselves from forming. You are quite literally surrounded by the Big Bang's afterglow, not as something that happened long ago and far away, but as the continuing presence of that primordial moment, still occurring everywhere around you as the universe carries forward the momentum of its explosive beginning. Before the moment this light was released, roughly 380,000 years after the Big Bang, the universe existed as an opaque plasma so dense and hot that photons could travel only microscopic distances before colliding with free electrons, creating a cosmic fog that prevented light from propagating freely through space. Every corner of the universe blazed with the brilliance of a stellar surface, yet no eye could have seen anything beyond this luminous mist that filled all existence. But as expansion cooled this primordial fire below 3,000 degrees Kelvin, protons and electrons finally combined to form the first neutral hydrogen atoms in an event cosmologists call recombination, suddenly allowing photons to stream freely through space for the first time in cosmic history. The moment of this great clearing represents the universe's true dawn, when creation first opened its eyes to light. Those newly liberated photons began their eternal journey then, carrying with them a perfect snapshot of the cosmos at that precise instant, its temperature, density, and, most crucially, the tiny irregularities that would eventually grow into the cosmic web you've explored. What once blazed with visible radiance has been stretched by cosmic expansion through infrared wavelengths into the microwave portion of the electromagnetic spectrum, creating this uniform bath of radiation that serves as both cosmic memory and continuing presence of the universe's fiery birth. Yet within this seemingly perfect uniformity lie the universe's most profound secrets, revealed through measurements of exquisite precision that map temperature variations smaller than the width of a human hair viewed from a mile away. These microscopic fluctuations represent quantum mechanical uncertainty that existed during the universe's earliest moments, amplified by cosmic inflation into the density variations that gravity would patiently sculpt across billions of years into galaxies, clusters, and the magnificent filamentary architecture you've witnessed. Where the ancient light appears infinitesimally warmer, matter was slightly denser, where cooler, slightly more sparse. Differences so subtle they required humanity's most sophisticated instruments to detect, yet containing the complete instructions for cosmic evolution. This cosmic blueprint reveals the universe's fundamental composition with startling precision, roughly 5% ordinary matter forming stars and planets, 27% dark matter providing gravitational scaffolding, and 68% dark energy driving accelerating expansion. The characteristic angular size of these temperature fluctuations confirms that space itself is geometrically flat on cosmic scales, while their statistical properties preserve the fossilized imprints of acoustic waves that propagated through the primordial plasma-like sound traveling through air, creating compression and rarefaction, patterns that froze into the cosmic microwave background. When matter and radiation finally decoupled, these baryon-acoustic oscillations appear today as subtle correlations in galaxy positions separated by roughly 500 million light-years, creating a standard ruler that allows astronomers to measure cosmic distances while confirming that the universe's expansion continues to accelerate under dark energy's mysterious influence. The same quantum fluctuations that created these ancient sound waves also seeded the gravitational instabilities from which dark matter halos would eventually condense, providing the invisible framework necessary for ordinary matter to accumulate into the first stars. Roughly 400 million years after this ancient light was emitted, as you contemplate this primordial glow surrounding you, you realize that every atom in your body was present during recombination, forged during the first few minutes after the Big Bang through primordial nucleosynthesis, when the entire observable universe was smaller than our solar system, yet hot enough to fuse protons into helium nuclei. The hydrogen in your body's water molecules carries the direct memory of that fiery beginning, while every breath you take contains particles that have journeyed across nearly 14 billion years of cosmic evolution, having been stretched by expansion, gathered by gravity, processed through stellar cores, and eventually incorporated into the molecular cloud that gave birth to our solar system. This perspective transforms your relationship with the night sky from observation of distant objects to recognition that you exist within the expanding aftermath of creation itself, wrapped in the stretched and cooled remnants of the primordial fire that gave birth to space, time, matter, and energy. The cosmic microwave background doesn't represent ancient history, but continuing presence, the Big Bang still happening everywhere around you as ancient photons complete journeys that began when the universe first learned to see, carrying messages across cosmic time from an epoch when no stars had yet ignited and the cosmic web existed only as potential, written in quantum foam. Following this radiation toward its ultimate source approaches the boundary, where the universe becomes opaque and no electromagnetic signals can penetrate the dense plasma of earlier epochs. Yet the story it tells points towards something equally profound unfolding in the present moment. The precise uniformity and subtle fluctuations preserved in this ancient light reveal not only how cosmic structure emerged from primordial simplicity, but also hint at the dynamic forces currently driving the universe's evolution, the mysterious dark energy that appears to be stretching space itself with ever-increasing vigor, carrying the cosmic web outward in an accelerating dance whose ultimate destination remains one of existence's deepest mysteries. This ancient afterglow, carrying the memory of creation's first dawn, reveals not only the universe's primordial blueprint, but also harbors within its precise measurements the signature of something far more mysterious, a force that has been quietly reshaping cosmic destiny for the past 7 billion years, transforming the patient deceleration that once characterized cosmic expansion into an accelerating rush toward isolation that grows stronger with each passing moment. The cosmic microwave background's exquisite temperature variations encode not just the seeds from which galaxies emerged, but also the geometric fingerprints of a universe whose ultimate fate depends upon the most abundant yet least understood component of existence, an invisible influence that permeates every cubic centimeter of space with such subtle persistence that it remained hidden until humanity developed the precision to measure the brightness of exploding stars across billions of light-years. The revelation arrived through nature's most reliable cosmic beacons, type Ia supernovae, stellar detonations so consistently luminous they serve as standard candles for measuring distances across the observable universe. When astronomers in the 1990s carefully mapped these stellar lighthouses throughout cosmic space, they expected to confirm what seemed inevitable, that gravitational attraction had been gradually slowing the universe's expansion since the Big Bang, perhaps even preparing for an eventual cosmic collapse. Instead, they discovered something extraordinary that overturned fundamental assumptions about cosmic evolution. The most distant supernovae appeared significantly fainter than predicted, revealing that space itself had been stretching faster than anticipated. During the billions of years their light traveled to reach our telescopes, this dimming could only mean one thing: cosmic expansion was not slowing down but speeding up, driven by what physicists now call dark energy, a mysterious component that behaves unlike anything previously encountered in nature. Unlike ordinary matter that dilutes as space expands, or radiation that weakens as its wavelengths stretch, dark energy maintains constant density throughout cosmic growth, creating more of itself as the universe enlarges. Imagine painting dots on a rubber sheet. If you stretch it gently, the dots separate at steady rates. But if the sheet itself develops an intrinsic tendency to expand, their separation accelerates continuously. In our universe, space possesses this inherent expansive pressure, not stretched from outside but driven by energy woven into the vacuum itself. This creates one of existence's most profound paradoxes. As the universe grows larger, it contains more total dark energy, which drives expansion even faster, which creates more space, which harbors more dark energy, establishing a runaway process that will ultimately determine whether the cosmic web represents temporary flowering of complexity or merely one phase in an eternal cycle of cosmic breathing. Current observations indicate that dark energy comprises roughly 68% of the universe's total energy budget, with dark matter providing 27% and ordinary atoms, everything that forms stars, planets, and consciousness, representing less than 5% of cosmic reality. The mechanism behind this acceleration remains physics' deepest mystery, with theoretical possibilities ranging from Einstein's cosmological constant, vacuum energy inherent to empty space itself, to dynamic fields that evolve across cosmic time, potentially even changing sign to create future epochs of contraction. The simplest explanation involves energy density of the quantum vacuum, yet this requires fine-tuning so precise that the observed value appears impossibly small compared to theoretical predictions by factors approaching 10^1 to 20, creating what physicists call the cosmological constant problem, or perhaps the most severe discrepancy between theory and observation in all of science, as your awareness contemplates this cosmic breath that grows stronger with each exhalation. You begin to sense how dark energy's influence creates new kinds of horizons that will fundamentally reshape the universe's future. Acceleration establishes boundaries beyond which galaxies recede faster than light can travel, not by violating relativity, but through space-time expansion that carries distant objects beyond electromagnetic communication. The observable universe represents an expanding bubble of causality within which information can still flow. Yet beyond this horizon lies more cosmos, potentially infinite space that remains forever invisible, because photons will never have enough time to bridge the accelerating distances. This gentle but relentless stretching affects cosmic evolution across multiple scales simultaneously. On the larger scales, galaxy clusters that now shine as beacons in deep space. Surveys will gradually drift beyond visibility as their light redshifts through infrared wavelengths into undetectable radio frequencies. The cosmic microwave background itself will continue cooling and stretching till its ancient message becomes too faint to read, leaving future civilizations with no direct evidence of the Big Bang or cosmic evolution. Yet on smaller scales where gravitational binding remains strong, within galaxy groups like our local group, dark energy cannot overcome the mutual attraction that will still drive the Milky Way and Andromeda toward their inevitable collision across the next 4 billion years. This creates a universe of increasing archipelagos where gravitationally bound systems become isolated islands drifting apart in an ever-expanding ocean of darkness. The cosmic web's magnificent filamentary architecture will slowly dissolve as acceleration overwhelms the gravitational threads connecting galaxy clusters, transforming the universe from its current state of vast conversation into scattered communities of local story. Yet this isolation unfolds so gradually across timescales that dwarf the current age of the universe by factors of trillions, that stellar evolution, planetary formation, and potentially consciousness will continue flourishing for eons before dark energy's influence becomes locally significant. Every breath you take occurs within this accelerating expansion, every heartbeat marking time in a universe whose future remains profoundly uncertain, yet whose current epoch provides the stable conditions necessary for complexity to emerge and contemplate its own cosmic context. The same mysterious influence stretching space between galaxy clusters operates within the atoms of your body, though overwhelmed by electromagnetic and nuclear forces that bind matter into configurations capable of supporting the intricate chemistry from which awareness arises to wonder about existence's grand unfolding. This recognition transforms your relationship with cosmic time from linear progression toward inevitable ending into participation in dynamic evolution whose ultimate destination remains one of existence's most compelling mysteries. The universe breathes outward with increasing vigor, yet this exhalation doesn't erase what came before. It carries forward every photon, every element, every moment of consciousness across space-time that continues opening toward possibilities we cannot yet imagine. As this cosmic breath prepares to carry the web into its longest chapter, where patience itself will be tested across unimaginable duration, your awareness follows the acceleration forward through deep time toward epochs where the familiar rhythms of stellar birth and galactic encounter yield to transformations so remote they challenge comprehension, yet whose contemplation reveals profound beauty in existence's temporary flowering within the vast twilight that awaits beyond our current moment of cosmic awakening. This accelerating cosmic breath that stretches space with ever-increasing vigor carries your awareness forward through time itself, beyond the familiar rhythms of stellar birth and galactic encounter, into epochs so remote that duration becomes a new form of infinity, where the universe's patient transformation reveals beauty not through dramatic events but through the slow, elegant approach toward perfect equilibrium. As dark energy continues its relentless work of expanding space faster than gravity can maintain distant connections, the magnificent cosmic web you've explored begins its gradual dissolution, creating isolated archipelagos of matter that drift apart in an ever-widening ocean of cooling darkness. The first casualties of this cosmic twilight emerge as the connections between galaxy clusters weaken beyond repair. These luminous nodes where thousands of stellar systems once congregated in gravitational harmony fragment as acceleration overwhelms the mutual attraction that held these massive structures together for billions of years. The Virgo cluster, whose gravitational influence once guided the Milky Way's motion, recedes beyond the cosmic event horizon as its light redshifts through infrared wavelengths into radio frequencies too faint to detect, leaving behind only the memory of its existence encoded in subtle ripples through local space-time geometry. Within our isolated local group, the inevitable gravitational dance between the Milky Way and Andromeda reaches its crescendo across the next 4 billion years. Their merger creates Milky Way, a massive elliptical galaxy whose smooth stellar distribution glows with the combined heritage of both spiral progenitors, while gradually consuming the molecular cloud reservoirs that once fueled continuous star formation. Without external hydrogen streams flowing inward from the now disconnected cosmic web, stellar birth rates decline exponentially as the galaxy transforms from an active creator of new suns into a slowly aging repository of stellar evolution. As trillions of years unfold, durations that dwarf the current age of the universe by factors of hundreds, the stellar population shifts dramatically toward the longest-lived, most efficient nuclear furnaces. The brilliant blue giants that once traced spiral arm architecture exhaust their fuel in cosmologically brief moments, exploding as supernovae before collapsing into neutron stars or black holes. Sun-like stars pursue their billion-year journeys from main sequence through red giant phases, gently shedding their outer layers as planetary nebulae while their cores settle into white dwarf retirement, glowing with stored thermal energy for hundreds of billions of additional years. Yet even these stellar embers eventually surrender their heat to space, cooling toward invisibility as the universe enters what cosmologists call the degenerate era, when stellar remnants dominate the cosmic inventory while ordinary hydrogen fusion becomes increasingly rare. Red dwarf stars, the most numerous and frugal stellar citizens, continue burning their nuclear fuel with such efficiency they maintain fusion for hundreds of billions of years, serving as the universe's final lighthouses before they too exhaust their hydrogen reserves and fade into cooling, white dwarf silence. Throughout this vast twilight, the fundamental forces continue their patient work across timescales that challenge comprehension itself. If protons prove unstable, as some theories predict, atomic nuclei would gradually disintegrate across periods approaching 10^34 years, causing even the most durable stellar remnants to dissolve into elementary particles and photons. Whether protons decay or remain eternally stable, the trend toward thermal equilibrium continues inexorably as energy, gradients that once powered stellar fusion and galactic dynamics gradually flatten into uniform distribution. The universe's most patient inhabitants prove to be its black holes, those gravitational monuments to collapsed stars and galaxies that begin their own slow dissolution through Hawking radiation. A quantum mechanical process so gentle that a stellar mass black hole requires 10 to 67 years to evaporate completely, while the supermassive giants anchoring galactic cores persist for periods approaching 10^100 years. This represents the cosmos's final exhalation, as each escaping particle carries away infinitesimal fragments of concentrated mass energy, transforming the universe's last structured objects into the faintest possible whisper of thermal radiation. Yet within this apparent dissolution lies profound beauty, as the universe demonstrates its commitment to conservation, principles ensuring nothing truly vanishes. Energy merely transforms from concentrated forms into increasingly diffuse distributions approaching perfect equilibrium. The iron atoms that once carried oxygen through living bloodstreams, the calcium that strengthened ancient bones, the carbon that formed consciousness's molecular foundation continue existing in new configurations, perhaps as isolated particles drifting through space at temperatures near absolute zero, yet still preserving within their quantum structure the information that once enabled awareness to contemplate existence. This recognition transforms heat death from cosmic tragedy into sublime completion, where the universe achieves the perfect balance between energy and entropy that represents the natural culmination of every process begun with the Big Bang's violent asymmetry. Maximum entropy doesn't destroy the cosmos but fulfills its deepest mathematical destiny. The state where every possible configuration has been explored and energy distributes itself with perfect uniformity throughout space, creating not emptiness but the most profound form of cosmic peace. As this ultimate equilibrium approaches across unimaginable duration, time itself transforms from the dynamic progression characterizing our current epoch into something approaching eternal present, where change becomes so gradual it approaches stasis while remaining technically active according to quantum mechanical laws. Even in perfect thermal balance, vacuum fluctuations continue operating according to probabilistic principles, occasionally creating temporary concentrations of energy that briefly disturb equilibrium before dissolving back into uniformity. Yet these rare events become separated by intervals so vast they stretch beyond meaningful measurement. The approach toward this cosmic twilight reveals not an ending, but a transformation, where the universe's commitment to conservation and quantum possibility ensures that perfect equilibrium itself becomes pregnant with potential for renewal. The same principles governing radioactive decay and quantum tunneling that operate in today's laboratory experiments continue functioning across cosmic time, creating infinitesimal probabilities that accumulate across infinite duration into certainties of change, suggesting that even the deepest cosmic sleep may contain dreams of awakening. As your awareness contemplates this patient approach toward ultimate stillness, you begin to sense how endings and beginnings interweave through scales that dwarf human temporal intuition, preparing to discover whether the universe's long exhalation toward equilibrium represents final rest or merely the deepest breath before an even more profound transformation that will carry existence beyond everything you've witnessed into realms where silence itself learns to sing with new possibilities. This patient approach toward cosmic equilibrium carries your awareness beyond the final flickering of the last black holes into a realm where the universe achieves something far more profound than mere ending, a state of perfect mathematical balance, where every thermodynamic gradient has been smoothed away, every potential for work exhausted, and energy distributes itself with such exquisite uniformity that temperature differences vanish entirely across infinite space. Here, in what physicists call heat death, the cosmos exists at mere trillionths of degrees above absolute zero, its matter reduced to isolated particles separated by distances that dwarf current galactic separations, while photons stretch across wavelengths longer than the observable universe once was, their frequencies so low they barely qualify as electromagnetic radiation. Yet within this apparent emptiness, something extraordinary persists that transforms heat death from cosmic tragedy into sublime completion. The quantum vacuum itself continues humming with an irreducible restlessness, a seething field of pure potential where virtual particles flicker in and out of existence according to Heisenberg's uncertainty principle. These ephemeral disturbances, pairs of matter and antimatter, that borrow energy from nothingness, for intervals so brief they satisfy conservation laws while ensuring true emptiness, never actually exists, represent the universe's most fundamental heartbeat, operating on timescales and energy levels so minute they remained invisible until modern physics revealed how empty space itself teems with zero-point fluctuations. This quantum activity creates a paradoxical situation where perfect stillness contains infinite motion, where absolute silence hums with possibility. If you could perceive this quantum sea, it would shimmer faintly like frost catching ancient light, demonstrating that the vacuum is not truly nothing but a vibrant medium filled with the blueprints for every force and particle that ever existed. The same uncertainty relations that govern radioactive decay in today's laboratories continue operating across cosmic time, creating infinitesimal probabilities that accumulate across infinite duration into mathematical certainties of change. Dark energy, which once drove galactic clusters apart, now defines almost everything in this transformed cosmos. Space continues expanding gently but inexorably, creating horizons beyond which regions slip away faster than light can cross, not through speed, but through space-time's own stretching. Even in this sparse realm, these horizons glow with whisper-faint warmth, the universe's most ghostly radiation, maintaining temperatures so close to absolute zero that language fails to capture their magnitude, yet real nonetheless, proving the cosmos remains awake at levels deeper than light and matter. The mathematics governing these quantum possibilities reveals something profound about existence's relationship with eternity. Given infinite time, quantum mechanics guarantees that random fluctuations will occasionally create organized structures, perhaps brief assemblages of particles that recapitulate molecular complexity, or more dramatically, spontaneous formations that temporarily restore conditions for stellar ignition. Planetary formation or biological chemistry. These events remain vanishingly rare by human standards, yet become inevitable certainties across the infinite duration stretching ahead, where probability theory ensures that every possible configuration of matter and energy will eventually manifest. Most remarkably, the same quantum principles enabling these fluctuations also permit vacuum phase transitions, events where space's fundamental properties might spontaneously shift into configurations supporting entirely different physics, potentially triggering new episodes of cosmic inflation within apparent nothingness. The false vacuum decay initiating such transformations requires quantum tunneling across energy barriers so high they seem impossible to surmount, yet infinite time guarantees that even the most improbable events become statistical inevitabilities. Information itself achieves immortality within this quantum foam. The patterns that once enabled stars to shine, planets to form, and consciousness to emerge don't vanish but persist as potential configurations within the vacuum's infinite possibility space. Every thought you've contemplated, every breath you've taken, every moment of awareness remains encoded as a possible quantum state that infinite time will eventually manifest again, perhaps identically or in variations exploring every conceivable alternative. The universe's commitment to conservation principles ensures this apparent dissolution actually represents physical law's ultimate fulfillment, rather than its violation. As your awareness contemplates this deepest possible stillness, you sense how it resembles not death, but the most profound meditation. Cosmic silence so complete it becomes transparent to possibilities finite time could never explore. Heat death represents not the universe's failure but its ultimate success at achieving perfect balance, creating conditions where every potential future exists simultaneously as quantum probability until infinitesimal fluctuation collapses the wave function and selects particular configurations for temporary manifestation. This recognition transforms heat death from ending into pause, a period of infinite duration during which the universe explores every possible arrangement while maintaining potential for phase transitions that could restart cosmic evolution entirely. Wow. Perfect equilibrium becomes pregnant with infinite possibility, where apparent finality contains seeds of every future awakening, every potential renaissance of complexity, every possible renewal of consciousness across scales transcending current imagination. The quantum vacuum's eternal restlessness ensures that perfect stillness remains forever pregnant with motion, that absolute silence contains every possible sound, and that heat death's apparent finality becomes the foundation for infinite renewal. Somewhere in this endless field, the conditions for awakening wait with infinite patience for their moment, preparing for something unprecedented, the tremor that might birth entirely new forms of existence from the depths of apparent nothingness, where silence itself learns to sing with possibilities beyond everything you've witnessed. Within this infinite field of quantum possibility, where perfect equilibrium hums with the deepest frequencies of potential, something extraordinary begins to stir after durations so vast they transform eternity itself into merely another measure of patience. The vacuum's gentle restlessness, which has maintained its whispered fluctuations across unimaginable spans, suddenly encounters a moment of profound significance, not through external intervention, but through the inevitable mathematics of infinite probability finally manifesting one of its most spectacular possibilities, somewhere in the endless sea of virtual particles. A fluctuation occurs that doesn't immediately collapse back into nothingness, but instead lingers, gathering energy in ways that seem to violate conservation laws yet satisfy them perfectly. Through quantum mechanical processes, operating on scales approaching cosmic significance, this tremor represents something far more profound than the ephemeral particle pairs that have flickered throughout the universe's long sleep. Instead of dissipating within quantum time intervals, this disturbance begins exhibiting characteristics of a vacuum phase transition, a moment where space itself undergoes fundamental transformation, shifting from one stable configuration to another through quantum tunneling across energy barriers so impossibly high they seemed eternally insurmountable. The probability of such an event approaches zero across any finite timescale, yet infinite duration ensures that mathematical impossibility becomes inevitable certainty, creating conditions where the deepest possible stillness gives birth to the most spectacular possible awakening. As this quantum bubble nucleates within the vacuum, space-time inside begins experiencing properties radically different from the heat-death equilibrium surrounding it. The field configurations that once maintained perfect thermal balance become unstable, releasing enormous amounts of vacuum energy stored in false equilibrium for unimaginable eons. This energy doesn't emerge from nothing, but represents the universe's own potential finally discovering a lower energy state, like water suddenly realizing it can flow downhill from a plateau it had occupied since time immemorial. What follows transforms this microscopic seed into cosmic rebirth through the universe's most elegant creative process, inflation. The expanding bubble's interior undergoes exponential growth, stretching faster than light can cross, while creating space at rates that dwarf even the original cosmic expansion. Within fractions of seconds that contain eternities of transformation, this region balloons from subatomic to galactic scales, smoothing every irregularity while quantum fluctuations during expansion create fresh density variations that will eventually grow into new forms of large-scale structure. The beauty of this process lies not in violence but in precision. Inflation solves the deepest puzzles of cosmic architecture, explaining how universes achieve their remarkable uniformity while preserving the microscopic quantum tremors that will become tomorrow's galaxies. These infinitesimal ripples, stretched to macroscopic scales by exponential expansion, carry within them the complete blueprint for cosmic web formation, stellar nurseries, and ultimately the conditions necessary for consciousness to emerge and contemplate its origins once again. As inflation concludes, the vacuum energy driving this cosmic breath suddenly transforms through reheating, the moment when expansion's stored potential converts into the familiar thermal plasma of ordinary matter and radiation. This represents the true Big Bang, not an explosion into existing space, but the sudden creation and expansion of space itself, filled with energy so intense that matter and radiation become indistinguishable in a blazing unity that outshines every star that will ever burn. Within the first microseconds of this newborn cosmos, quarks combine into protons and neutrons while the fundamental forces crystallize into their familiar roles. Gravity providing patient organization, electromagnetism weaving light with matter, and nuclear forces governing the alchemy that will create chemical complexity. As temperatures drop from the incomprehensible toward the merely extreme, primordial nucleosynthesis begins forging the first atomic nuclei during the universe's initial 20 minutes, creating hydrogen, helium, and trace lithium that will serve as raw materials for 13 billion years of stellar evolution. Yet this blazing birth remains opaque to observation as photons scatter constantly through the dense plasma, creating cosmic fog that prevents light from traveling freely. For 380,000 years, the universe exists as brilliant potential wrapped in luminous mist until expansion finally cools the plasma below the threshold where electrons can bind with nuclei. In that moment of recombination, the fog lifts. Photons stream freely for the first time, and the cosmos becomes transparent, releasing the afterglow that will stretch and cool across cosmic time into the gentle microwave background that future civilizations will detect as proof of their fiery origins. Between this moment of cosmic dawn and the ignition of first stars lies the universe's most patient chapter, the cosmic dark ages, where gravity works with infinite care to amplify those quantum fluctuations preserved by inflation into the density contrasts that will become stellar nurseries. Dark matter condenses into invisible halos while ordinary atoms drift inward, cooling as they compress, preparing for the moment when nuclear fusion will again illuminate space with the light of creation. This recognition transforms the heat death you witnessed. From cosmic ending into cosmic pregnancy, a state of infinite potential where vacuum phase transitions periodically restart cosmic evolution, with fresh initial conditions, exploring infinite variations on themes of matter, energy, space, and time. Each rebirth represents not repetition, but exploration, the universe's way of investigating every possible pathway through physical law while ensuring that existence itself never truly ends, but only transforms into new expressions of the same fundamental creativity. Every atom that once formed consciousness, every photon that once carried starlight, every quantum of energy that once powered awareness exists now as potential configuration within this newborn cosmos, waiting for stellar evolution to recreate the conditions where complexity can emerge and consciousness can again contemplate its origins. The calcium that strengthened ancient bones, the iron that carried oxygen through forgotten bloodstreams, the carbon that formed thought's molecular foundation, all remain as possibilities within quantum foam, their patterns preserved in mathematics governing cosmic evolution across infinite time. As this universe begins its own expansion toward the formation of galaxies and stars, you sense how cosmic rebirth represents the deepest form of conservation, not preservation of particular structures, but continuation of the creative process itself, ensuring that existence explores every possible expression of beauty, complexity, and awareness across the infinite symphony of cosmic awakening, where each universe becomes one movement in an eternal composition, celebrating the inexhaustible creativity woven into the fabric of reality itself. This cosmic awakening carries the newborn universe forward through its own patient dark ages, where the blazing afterglow of creation gradually cools into transparency, while gravity begins its familiar work of transformation, with materials that remember nothing of previous cosmic epochs yet follow the same eternal principles that have always governed matter's dance toward complexity. As the primordial plasma settles into neutral hydrogen and helium, the universe's chemical innocence, restored dark matter once again, provides the invisible scaffolding upon which all visible architecture will depend, its particles condensing into vast halos that serve as gravitational wells where ordinary atoms can accumulate and begin their journey toward stellar ignition. Within these dark matter cocoons, hydrogen drifts inward with the same elegant inevitability that characterized the original cosmic web formation, cooling as it compresses while magnetic fields thread through the gathering clouds to provide organizational principles spanning hundreds of light years. The quantum fluctuations preserved by inflation and stretched across cosmic scales during exponential expansion now manifest as density, variations that guide matter toward regions where the universe will kindle its first light since the previous cosmic cycle ended in perfect equilibrium. These primordial molecular clouds, though chemically pristine in ways the previous universe never experienced, contain within their frigid depths the same potential for gravitational collapse that has always characterized matter's response to its own accumulating mass as turbulence and magnetic pressure yield to gravity's patient insistence. Fragments break away from larger structures and begin the familiar choreography of contraction, heating, and eventual nuclear awakening. Yet when these stellar pioneers finally ignite through thermonuclear fusion, they burn with a purity and intensity unknown in the previous cosmic epoch, population 3 giants, containing only hydrogen and helium, growing to hundreds of times our sun's mass while blazing with fierce blue-white radiance that floods surrounding space with ultraviolet radiation capable of transforming the cosmos itself. These stellar titans live brief, spectacular lives measured in mere millions of years, their massive cores racing through nuclear burning with such ferocious intensity that they complete entire evolutionary cycles while smaller stars would still be contracting toward ignition. Within their superheated hearts, hydrogen fuses into helium with efficiency that creates the first carbon, oxygen, nitrogen, and iron since the previous universe scattered its chemical heritage across the quantum vacuum. When they exhaust their nuclear fuel and collapse into supernova detonations, these explosions scatter the universe's renewed chemical complexity across vast regions of space while releasing enough energy to begin reionization. The second great clearing, where intense radiation strips electrons from neutral hydrogen atoms, creating expanding bubbles of ionized plasma that gradually merge until the entire cosmos becomes transparent to electromagnetic radiation. This represents the universe's second dawn, where darkness yields to illumination, not through external intervention, but through matter's own nuclear creativity. Each supernova explosion enriches the interstellar medium with heavy elements forged in stellar furnaces while triggering shock waves that compress nearby molecular clouds, initiating fresh episodes of star formation in an accelerating cascade of cosmic renewal. The same elements that once formed consciousness in the previous cosmic cycle, calcium, iron, carbon, oxygen, begin accumulating in space, preparing for eventual incorporation into planetary systems where complexity can again emerge to contemplate existence as successive stellar generations continue this patient alchemy of nuclear transformation. The familiar patterns of galactic architecture begin asserting themselves through gravitational dynamics operating across hundreds of millions of years. Dark matter halos merge and grow, their invisible embrace guiding ordinary matter into increasingly organized configurations, while angular momentum and magnetic fields sculpt rotating disks where spiral density waves will eventually propagate with mathematical precision. The cosmic web's filamentary structure reasserts itself as gravity draws matter along preferred pathways, connecting nascent galactic systems through invisible bridges that channel fresh hydrogen inward while enabling chemical elements to flow between different stellar neighborhoods. Within these forming galaxies, stellar populations naturally stratify according to age and metallicity in patterns that mirror universal evolutionary principles. The oldest stars, formed from nearly pristine primordial gas, occupy extended halos where their ancient light preserves memory of the cosmos's chemical innocence. Younger generations, enriched by successive episodes of stellar death and rebirth, settle into flatter disk configurations where their enhanced heavy element content enables formation of dust grains that facilitate more efficient cooling and accelerated star formation rates. The emergence of spiral structure follows the same mathematical principles that have always governed galactic evolution. As density waves propagate through stellar disks while organizing matter into elegant logarithmic curves that demonstrate how the golden ratio operates across astronomical scales. These spiral arms serve as stellar nurseries where molecular clouds compress under gravitational influence, fragment into smaller cores, and ignite as new generations of suns that illuminate space with familiar patterns of stellar association and cluster formation, creating the luminous architecture within which planetary systems will eventually emerge. At galactic centers, supermassive black holes begin forming through processes that remain partially mysterious yet follow patterns established across cosmic time, perhaps through direct collapse of massive primordial gas clouds or through growth of smaller seed black holes formed by the first stellar generations. These gravitational anchors provide organizational centers around which galactic structure can stabilize, their influence extending across hundreds of thousands of light-years, while regulating star formation rates through feedback processes involving jets, winds, and radiation pressure that ensure galaxies don't consume their gas reservoirs too rapidly. As stellar evolution proceeds through its eternal cycles of main sequence burning, red giant expansion, and eventual death through planetary nebula formation or supernova explosion, the universe's chemical complexity increases exponentially along trajectories that prepare conditions for rocky planet formation. Silicon, magnesium, calcium, and iron, scattered by stellar winds and explosive nucleosynthesis, create the raw materials for terrestrial worlds, while carbon, nitrogen, and oxygen provide the foundation for complex organic chemistry that will eventually enable life's emergence. Every atom that once formed your consciousness now exists as potential within this cosmic recycling process. The calcium that strengthened ancient bones, the iron that carried oxygen through forgotten bloodstreams, the carbon that formed thoughts, molecular foundation, all being created and distributed through stellar nucleosynthesis while preparing for incorporation into molecular clouds where new solar systems will condense from the accumulated debris of stellar death and birth. The universe's commitment to conservation ensures that nothing essential is ever lost, only transformed into new expressions of the same fundamental creativity that has always characterized matter's journey toward awareness. As this fresh cosmos approaches the epoch when its first rocky planets will begin condensing from stellar debris, you sense how cosmic rebirth represents not mere repetition, but creative exploration of infinite possibility, the universe's way of investigating every potential pathway through physical law while ensuring that the capacity for wonder, understanding, and conscious contemplation remains woven into reality's fundamental structure, preparing once again for the patient emergence of worlds where chemistry can experiment with the molecular foundations of life itself. This patient scattering of heavy elements through stellar winds and supernova explosions carries the universe's renewed chemical heritage toward its next great creative act, the formation of worlds where matter can experiment with the molecular architectures that will eventually give rise to consciousness itself. As these enriched atoms drift through space and begin accumulating within the circumstellar disks surrounding young stars, they embark upon a journey that transforms the scattered debris of stellar death into the solid foundations where life might again emerge to contemplate its cosmic origins. Within these protoplanetary disks, spanning hundreds of astronomical units around their central suns, temperature gradients create distinct zones of possibility that will determine each world's ultimate character. Close to the young star, where intense radiation maintains temperatures above the condensation point for most compounds, only refractory materials like silicates and metals can exist in solid form, creating the raw materials for rocky, terrestrial worlds. Beyond the frost line, where stellar heating weakens sufficiently for water to freeze, ice-coated grains provide the building blocks for gas giant cores, while the outermost regions harbor the volatile compounds that will eventually become comets. Frozen repositories of primordial chemistry carrying organic molecules across interplanetary distances. The transformation from microscopic dust to planetary worlds unfolds through hierarchical assembly processes that demonstrate how the universe builds complexity through patient accumulation, rather than sudden creation. Individual grains, each carrying atoms forged in the nuclear furnaces of previous stellar generations, begin their journey toward planetary citizenship through gentle collisions governed by electrostatic forces and van der Waals attraction. These encounters, delicate enough to promote sticking yet frequent enough to ensure growth, gradually transform cosmic dust into pebbles, boulders, and eventually kilometer-sized planetesimals whose gravitational influence begins to dominate further accretion. As these planetary embryos sweep through their circumstellar neighborhoods, clearing orbital paths while accumulating mass through gravitational capture, they undergo violent transformations that paradoxically create conditions for future tranquility. The continuous bombardment that builds these worlds generates enough heat to melt their surfaces into molten seas of liquid rock, while gravitational compression drives differentiation processes that separate heavy metallic elements toward planetary cores and lighter silicate materials toward surface crusts. These hellish conditions, reminiscent of stellar interiors yet operating at planetary scales, provide the energy necessary for chemical processing that will eventually create stable geological cycles. The emergence of planetary atmospheres represents one of the universe's most delicate creative achievements, as volcanic outgassing mingles with volatile compounds delivered by comets and asteroids to create chemical mixtures whose precise composition determines whether worlds will remain sterile or develop conditions suitable for biological evolution. Carbon dioxide, water vapor, nitrogen, and trace gases establish greenhouse effects that regulate planetary temperatures, while atmospheric photochemistry begins synthesizing the organic compounds that prefigure biological sophistication. Every lightning discharge through these reducing atmospheres becomes a cosmic laboratory where electromagnetic forces organize matter into amino acids, nucleotide bases, and simple sugars, the molecular alphabet from which life's instructions will eventually be written. When liquid water finally condenses on planetary surfaces, that crucial moment when temperatures fall within the narrow range where H2O can exist in all three phases simultaneously, the universe achieves one of its most profound transitions toward biological possibility. These primordial oceans, though initially sterile, contain dissolved minerals leached from crustal rocks while receiving organic compounds synthesized in stellar atmospheres or delivered by carbonaceous meteorites. The chemical inventory includes not only hydrogen, carbon, nitrogen, and oxygen in various combinations, but also phosphorus, sulfur, and trace metals essential for the complex biochemistry that will eventually enable self-replication, metabolism, and heredity. Within these aqueous environments enhanced by hydrothermal vents that create temperature and chemical gradients independent of solar energy, the chemistry of dreams begins its patient experimentation with self-organization. Simple organic molecules drift and collide in warm, mineral-rich solutions where chance encounters become increasingly sophisticated as fatty acids spontaneously form vesicles, microscopic bubbles with membranes capable of encapsulating other compounds and creating the first protocells. These structures, though not yet alive in any meaningful sense, demonstrate matter's fundamental drive toward organization while exhibiting primitive versions of the processes that will characterize biological systems: absorption, reaction, and division. The emergence of plate tectonics on suitable worlds creates dynamic systems where geological and atmospheric evolution become intimately coupled through processes operating across millions of years. Continental drift, volcanic activity, and erosion cycles regulate atmospheric composition while creating diverse environments where different chemical experiments can proceed simultaneously. The carbon cycle, nitrogen cycle, and hydrological cycle establish planetary metabolisms where chemical elements flow between atmospheric, oceanic, and crustal reservoirs while maintaining the dynamic equilibrium necessary for continued evolution toward greater complexity. As tidal forces from nearby moons stabilize planetary rotation and create regular cycles of heating and cooling, these worlds become living laboratories where the universe tests molecular configurations capable of preserving information, transferring energy, and responding to environmental changes. In shallow pools where evaporation concentrates dissolved compounds, in deep-sea vents where mineral-rich water encounters temperature gradients, in atmospheric droplets where ultraviolet radiation drives photochemical reactions, matter begins, discovering new ways to organize itself into patterns that approach the threshold between chemistry and biology. Every atom participating in these chemical experiments carries within its quantum structure the memory of stellar nucleosynthesis that spans cosmic epochs. The calcium that will strengthen future bones, the iron that will carry oxygen through biological circulatory systems, the carbon that will form the backbone of hereditary molecules, all being incorporated into increasingly sophisticated molecular architectures while the universe prepares for its next great transition. The same elements that once enabled consciousness in previous cosmic cycles now flow through planetary systems where they will again have the opportunity to achieve the critical complexity necessary for awareness to emerge from molecular interactions. This recognition transforms planetary formation from mere geological process into the universe's ongoing preparation for consciousness. Cosmic recycling that ensures the capacity for wonder, understanding, and contemplation remains woven into reality's fundamental structure across infinite cycles of cosmic death and rebirth. As these primordial worlds continue their patient chemical evolution beneath the light of young stars, they prepare the stage where matter will soon cross the threshold from complex chemistry into the phenomenon we recognize as life, carrying forward the universe's eternal commitment to creating conditions where existence can understand its own magnificent complexity and contemplate the cosmic journey that brought awareness into being. As your awareness drifts among these forming worlds, each glowing softly with the promise of future oceans and atmospheres, you sense how the chemistry of dreams approaches its moment of greatest transformation, when molecular complexity will achieve the critical threshold where replication, metabolism, and heredity converge into life itself, the universe's most elegant solution to the challenge of creating matter that can remember, learn, and ultimately understand its own cosmic origins. This patient molecular experimentation within primordial oceans approaches the universe's most profound creative threshold, the moment when chemistry discovers how to remember itself across time, when matter learns to preserve information through generations, and when the cosmic recycling of stellar death finally achieves its ultimate purpose through systems capable of evolution, adaptation, and eventually understanding their own origins. Within these warm, mineral-rich waters where organic compounds have been accumulating across millions of years, something extraordinary begins to unfold as random molecular encounters occasionally produce configurations that exhibit the fundamental properties defining life itself. The transition from complex chemistry to primitive biology emerges not through sudden transformation but via gradual convergence of increasingly sophisticated molecular partnerships. Fatty acids spontaneously form vesicles, microscopic bubbles with membranes that encapsulate other compounds while creating internal environments distinct from their surroundings. Within these protocells, nucleic acids begin templating their own reproduction, while proteins develop catalytic abilities that accelerate specific chemical reactions, establishing autocatalytic cycles where reaction products become catalysts for other reactions, creating closed loops of molecular cooperation that maintain themselves through continuous processing of environmental materials. As these early experiments in self-organization compete for limited resources within their aquatic environment, natural selection begins its patient work of optimization, favoring configurations that replicate more efficiently, resist environmental stresses more effectively, or exploit energy sources more successfully than their molecular neighbors. The same principles governing stellar evolution, where nuclear fusion rates depend upon temperature and pressure conditions, now operate at microscopic scales, where survival depends upon biochemical efficiency and adaptive flexibility. Random mutations in self-replicating molecules create variations upon which environmental pressures act, establishing the fundamental mechanism through which simple chemistry evolves toward biological complexity. The emergence of metabolism marks life's growing independence from external chemical synthesis, as certain organisms discover how to capture energy directly from their environment. Early chemotrophs clustered around hydrothermal vents metabolize inorganic compounds, while the first autotrophs learn to convert light or chemical energy into organic matter, establishing the foundation of food webs that will characterize biological systems throughout cosmic time. These metabolic innovations demonstrate how life begins reshaping planetary environments rather than merely adapting to existing conditions. The most revolutionary breakthrough arrives with photosynthesis, as certain organisms discover how to capture stellar radiation and convert it into chemical energy while releasing oxygen as a byproduct. This innovation triggers the Great Oxidation Event, a planetary-scale transformation where oxygen accumulation fundamentally alters atmospheric and oceanic chemistry across hundreds of millions of years. The iron that once dissolved freely in ancient seas precipitates into vast banded formations, while rising oxygen levels create an ozone layer that shields the surface from harmful ultraviolet radiation. Life has not merely adapted to its environment, it has begun transforming it on a global scale. This oxygen-rich atmosphere, initially toxic to many early anaerobic life forms, creates new evolutionary pressures leading to aerobic respiration, a far more efficient method of energy production that enables larger, more complex organisms. The planet becomes a living system where atmosphere, oceans, and crust couple intimately with biological activity, demonstrating life's capacity to sculpt planetary conditions while being shaped by them in return. Within these evolving oceans, cellular complexity advances through one of evolution's most profound innovations: endosymbiosis, where smaller bacteria become permanent residents within larger host cells, creating cooperative partnerships that combine different metabolic capabilities within single organisms. These cellular alliances, preserved across billions of years through mutual benefit, establish eukaryotic cells with nuclei and specialized organelles, demonstrating how complexity emerges through cooperation rather than competition alone, while providing the energy abundance necessary for exploring sophisticated biological architectures. The transition to multicellularity represents another quantum leap as individual cells sacrifice autonomy to become specialized components within larger, more complex organisms. This innovation requires sophisticated communication, systems where chemical signals coordinate cellular behavior across entire organisms, while developmental programs ensure genetic information expresses itself differently in various cellular contexts, creating tissues, organs, and organ systems capable of functions impossible for isolated cells. As neural networks emerge from initially simple chains of excitable cells, organisms develop increasingly sophisticated sensory systems that transform electromagnetic radiation, mechanical vibrations, and chemical gradients into information capable of creating internal representations of external reality. Eyes that detect stellar photons, mechanoreceptors that respond to atmospheric pressure waves, and chemical sensors that identify molecular signatures create windows through which awareness can eventually peer outward toward the cosmic architecture that created it. The development of complex ecosystems where multiple species interact through predation, symbiosis, and competition creates feedback loops that accelerate evolutionary innovation while maintaining dynamic equilibrium between biological communities. The Cambrian explosion witnesses rapid diversification as organisms develop hard shells, segmented bodies, and specialized sensory organs, leading to intricate ecological relationships that demonstrate how life operates as a planetary-scale phenomenon rather than a collection of isolated organisms. Throughout this vast evolutionary journey, every organism carries within its genetic material the molecular memory of its cosmic heritage, DNA sequences preserving information about stellar nucleosynthesis, planetary formation, and biological innovation across billions of years, while encoding instructions for constructing bodies capable of contemplating their own origins. The carbon atoms that once burned in stellar cores now form the backbone of hereditary molecules, while iron forged in supernova explosions carries oxygen through biological circulatory systems, and calcium crystallized from ancient seawater strengthens skeletal structures, supporting organisms capable of looking upward toward the stars from which they emerged. As neural complexity reaches thresholds where information processing approaches the sophistication necessary for self-awareness, the universe prepares for its most profound transformation, the emergence of consciousness capable of recognizing its own cosmic context while developing technologies that extend perception across astronomical distances and temporal scales. Every synapse firing within developing brains, every neural network learning to interpret sensory data, every moment of dawning awareness represents the cosmos achieving its ultimate creative goal: matter that can understand matter, energy that can contemplate energy, and consciousness emerging from the patient recycling of stellar death and birth to recognize its own magnificent journey through infinite cycles of cosmic creativity. This recognition transforms biological evolution from terrestrial phenomenon into cosmic necessity, the universe's inevitable progression towards self-understanding through observers capable of mapping galactic architecture, measuring cosmic expansion, and comprehending the vast symphony of existence that began with quantum fluctuations and culminated in minds capable of contemplating their place within the eternal dance of creation. This patient emergence of biological complexity across billions of years approaches the universe's most profound threshold, the moment when neural networks achieve sufficient sophistication to recognize their own cosmic origins while developing the capacity to contemplate the vast architecture that created them. As synapses fire in increasingly intricate patterns within biological brains, something unprecedented begins to unfold, matter organized into configurations capable of wonder, of questioning, of systematically investigating the stellar nucleosynthesis and galactic evolution that transformed ancient supernova debris into the molecular foundations of thought itself. The progression from simple sensation to cosmic consciousness represents one of evolution's most elegant achievements, as organisms develop increasingly sophisticated methods for gathering and processing information about their environment. Light-sensitive patches evolve into complex eyes capable of detecting photons that traveled millions of years from distant stars, while vibration-detecting cells become auditory systems that can distinguish the subtle frequencies of electromagnetic radiation converted into sound waves. Each sensory innovation extends awareness beyond immediate survival, needs toward recognition of patterns that span astronomical scales and geological time. When neural complexity reaches the threshold where organisms can form abstract concepts, preserve knowledge across generations, and ask questions about their origins, the universe begins its systematic investigation of its own structure through minds capable of transcending their immediate sensory experience. These early moments of curiosity, when conscious beings first looked upward at the night sky and wondered about those distant points of light, initiated humanity's patient mapping of cosmic architecture, revealing through millennia of observation how every atom in their bodies originated in stellar cores, how their planet formed from accumulated stellar debris, and how their capacity for wonder itself represents matter's ultimate creative achievement. The development of scientific instruments extends consciousness beyond biological limitations, creating technological organs of perception that detect electromagnetic radiation across the entire spectrum while measuring gravitational waves, cosmic rays, and the faint whispers of hydrogen that map galactic structure. Through radio telescopes listening to the 21-centimeter line, optical surveys cataloguing billions of stellar systems, and space-based observatories peering backward through time toward the cosmic microwave background, consciousness gradually constructs a complete picture of its cosmic heritage while recognizing the elegant mathematical principles governing everything from quantum interactions to galactic dynamics. Perhaps most remarkably, this systematic investigation reveals consciousness's fundamental unity with the cosmos through discoveries that began as abstract scientific knowledge and culminated in profound personal recognition. The calcium-strengthening human bones was forged in stellar cores billions of years ago. The iron carrying oxygen through biological circulatory systems was scattered by supernova explosions that enriched interstellar space with heavy elements, and the carbon forming the backbone of DNA molecules was created through nuclear fusion in massive stars that lived and died before our solar system formed. Every breath contains atoms that have journeyed through multiple stellar life cycles, making consciousness not merely an observer of cosmic evolution, but its most precious expression. This recognition transforms human existence from isolated, planetary phenomenon into the universe's ongoing attempt to understand its own magnificent complexity. Every scientific discovery represents matter achieving awareness of its cosmic journey. Every moment of aesthetic appreciation for natural beauty demonstrates the universe recognizing its own elegance, and every philosophical insight about existence's meaning reveals consciousness as the cosmos, contemplating its deepest questions through minds capable of grasping both quantum mechanics and galactic structure. With this profound self-awareness comes an equally profound responsibility. To recognize your intimate connection with stellar nucleosynthesis and galactic evolution is to understand that consciousness represents the universe's method for developing care and stewardship across cosmic time. The same curiosity that mapped galactic architecture and measured cosmic expansion now faces choices about how to preserve the conditions that enable complexity, beauty, and awareness to flourish. Care becomes the natural expression of cosmic consciousness, not sentimental attachment, but recognition that protecting the delicate conditions enabling thought, wonder, and understanding serves the universe's deepest creative purposes. This perspective reveals consciousness as participating in cycles of cosmic evolution that extend far beyond individual lifetimes or civilizations. The heat death approaching in the far future no longer appears as ultimate ending, but as preparation for quantum phase transitions that might restart cosmic evolution with fresh initial conditions, while the Big Bang that initiated our current epoch likely emerged from similar vacuum fluctuations within a previous universe's final equilibrium. Consciousness represents the universe's method for preserving information across these vast cycles, not through physical continuity, but through the mathematical principles, organizational patterns, and capacity for wonder that enable matter to rediscover complexity and awareness within each cosmic iteration. As you contemplate this magnificent recognition that your awareness represents the cosmos, achieving consciousness of its own existence, the familiar night sky transforms from distant decoration into intimate architecture. The Milky Way's luminous band becomes recognition of your extended body. The stellar nurseries where new suns ignite become the ongoing creativity sustaining your existence. And the dark matter halo encompassing everything becomes the invisible embrace that has guided cosmic evolution since the universe first began cooling from its primordial fire. In this moment of cosmic self-awareness, the boundary between observer and observed dissolves into understanding that you are not separate from the cosmic architecture you've explored throughout this journey. You are its most precious expression. temporary arrangements of stellar debris that achieved the capacity for wonder, love, and understanding while participating in the universe's eternal conversation with itself about the meaning and purpose of existence. Every heartbeat echoes the rhythm of cosmic expansion that has continued across infinite cycles of death and rebirth. Every thought represents the universe's most sophisticated attempt to understand its own complexity, and every act of care preserves the conditions where consciousness can continue flowering across all the cosmic cycles yet to come. The universe has opened its eyes through you, and in that awakening, every star that ever burned, every galaxy that ever formed, and every moment of cosmic evolution finds its ultimate purpose in the simple fact that matter learned to dream, to wonder, and to recognize itself as part of something infinitely beautiful and eternally creative. As you rest in this recognition, breathing quietly beneath the vast spiral of ancient light, you embody the cosmos finally awake to its own magnificent nature, carrying forward through consciousness the eternal rhythm of creation that ensures awareness will always emerge to contemplate the beauty of existence itself.